So today we're going to go back and talk about a very exciting galaxy that was originally discovered back in 2015. Back then, this was the farthest galaxy known to us, the galaxy GN-Z11. And the Z11 here stands for the redshift. The redshift of this galaxy back then made it the farthest object we've ever seen, existing approximately 13.4 billion years ago, or approximately 400 million years after the Big Bang. And although since then, James Webb Space Telescope discovered something that's even a little bit farther, even today, GN-Z11 is still one of the most exciting and most studied distant galaxies ever. And as you're going to learn in this video, there have been a few really exciting discoveries coming out of this galaxy, taking us a little bit closer to solving a few cosmological mysteries. And so, hello wonderful person, this is Anton. Let's discuss this galaxy once again, talk about some of the more recent discoveries that came out of two separate studies, and of course talk about why some of these discoveries are kind of important. But first, so exactly what is this? Well, based on some of the preliminary discoveries, we know that this galaxy is about 4% the size of the Milky Way and contains about 1% of the mass. So it's actually relatively small, technically a dwarf galaxy. But it's also ridiculously bright. It's forming stars at least 20 times as fast and is producing an enormous amount of light, making this an extremely luminous object visible from very far away. How far away? Well, if you consider the expansion of the universe, 32 billion light years away from us. Once again, redshift of almost 11. In comparison, here's what the record holder looks like, the one discovered by the James Webb. This is at a redshift of 13.2 and just a little bit farther away, 33.6 billion light years, and definitely does not look as impressive or as bright. Actually, at least one study we've discussed previously even suggested that maybe, just maybe, this is not a galaxy, but instead some kind of a dark star made out of primordial dark matter. You can learn more about this in one of the videos in the description. But a lot of recent studies actually focused on something a little bit more detailed. They used observations from the James Webb to study spectroscopy, or in essence, how the light changes by passing through various gases inside the galaxy in order to reveal what sort of elements are inside, but also reconstruct the overall structure of gas in a galaxy, potentially discovering certain mysteries. Now, because James Webb is so powerful, it's physically able to see a lot of chunks of gas at really far away distances, and it can even tell us what sort of gas this is. And one of the recent studies discovered that there is a really high concentration of super dense gas somewhere in the center, and specifically a very thick, very dense gas that seems to contain a lot of ionized elements that are very likely created by something extremely powerful, with the first assumption of course being a supermassive black hole. But just seeing gas was not enough, so the researchers behind the recent study decided to find a few more clues. So first of all, in order to ionize elements, something really powerful has to happen in the vicinity. But turns out that these ionized elements were also moving really fast, approximately 800 to 1000 kilometers per second compared to the rest of the galaxy, suggesting that something was spewing them out. The only way to explain this outflow velocity is once again with a massive black hole. Although here what we're observing are the galactic winds, basically all of this gas being thrown out of the galaxy by a very powerful active galactic nucleus or active black hole in the center that's transforming everything inside the galaxy through a lot of vigorous activity right in the middle. And so here, by analyzing the speed of gas, the total mass of gas, and by looking at the density in the center, the researchers discovered a few more details about what it is. A black hole approximately 2 million solar masses in mass that seems to be accreting material 5 times the normal limit, what we refer to as the Eddington limit. Which basically means that it's so ridiculously bright that the light produced by the black hole sort of pushes everything out of the system, even counteracting gravity. And because in this case, all of the spectroscopy or all of the colors seem to indicate that this is a black hole and nothing else, it actually means that we now officially have the farthest supermassive black hole ever seen. But since it's about 2 million solar masses, or approximately half the mass of the one in the Milky Way galaxy, it is a little bit surprising. I mean, since this galaxy is only 1% the mass of the Milky Way, but contains such a huge black hole, it's not entirely clear how all of this could have formed so quick. Here it's believed that the stars are only about 40 million years old, and so that means that all of this possibly formed really quickly. But James Webb might have actually solved one of these mysteries of ancient black holes in one of the recent studies that you can learn more about in one of the videos in the description. And so anyway, looks like we have the most distant active black hole ever seen. But this wasn't the only discovery coming from the galaxy and coming from that James Webb data. Here it was also able to analyze other gas clouds, specifically various clumps surrounding the galaxy, not really in the center. And intriguingly, what they found was a huge concentration of helium gas. Actually, a huge clump of helium that seems to surround JWST. And since there's only helium and hydrogen forming extremely dense clumps, this kind of corresponds to a really intriguing proposition from a few years ago. An idea that a lot of these helium clumps very likely eventually result in population 3 stars. The mysterious primordial first stars in the universe made entirely out of hydrogen and helium and nothing else. And one of the primary missions for the James Webb is to try to find evidence for these stars. Or even better, actually see them somewhere. But so far evidence has been kind of sparse. This though is the best evidence we have. These tiny concentrated pockets of helium, extremely close to a massive galaxy in the first billion years, is actually how the scientists expect population 3 stars formed through the process of direct collapse of all of these clouds into these really massive super hot objects. Objects that would be at least 500 solar masses in mass and possibly up to several thousand masses, with all of them burning with extreme heat and very likely just exploding completely once they become unstable. And so these are definitely not like any stars around us and will be something very extreme, extremely huge in size and producing massive explosions. But because their lifetime is expected to be really short, possibly just a few thousand years or maybe even shorter, trying to capture that one frame where many of them existed has been so far really difficult. And so basically here, we either find gas before these stars formed, or in some cases find gas that seems to indicate supernova from these stars, something we actually discussed in one of the recent videos about a potential discovery right here in the Milky Way. So yeah, there was a star found here that must have been created from a supernova from one of these stars. But trying to find evidence of the actual stars still existing so far has been very difficult. But since a lot of these very thick clouds of helium potentially existed for millions of years after the Big Bang, chances are there were several periods during which these unusual stars could have formed. And so one day we might actually find one of them, as long as we keep looking. But what's actually exciting about this discovery of these helium clouds is that some of them are once again ionized. And ionized helium, specifically the one that's seen in this case, has always been believed to be a sign of population 3 stars illuminating the clouds around them. And intriguingly, if this is correct and if these are indeed clouds illuminated by these super powerful stars, then these stars must be super bright. The luminosity for a single star here is approximately 20 billion times higher than the Sun. So yeah, let me repeat that again. 20 billion times more luminous than our Sun. And that makes it a ridiculously bright object. And so unless there's another explanation for why these helium clouds are the way they are, right now this seems to be the best evidence we have for the existence of primordial population 3 stars. Although technically there was another study from a few months ago that potentially found signs of these population 3 stars in a different location. This was from a stellar complex known as LAP1, which is an acronym for Lensed and Pristine. Pristine because it doesn't seem to contain anything except for very basic elements. But interestingly, a lot of these elements are extremely ionized, once again suggesting something super powerful, very likely with a lot of UV light, hiding somewhere in the middle. And so back then in 2023, the researchers believed that this is also the sign of population 3 stars that seem to be present in some kind of a growing galaxy. But the evidence was not as strong as the evidence from JWST. Right now, what we're seeing from this distant galaxy is extremely difficult to argue with. There's basically no other explanation for this ionized helium except for very powerful, extremely massive stars somewhere in the center. And stars way too bright to be anything but huge chunks of hydrogen and helium, hundreds of solar masses in mass. But we're probably not going to know more until future studies and until future observations. For now, this is going to remain just a hypothesis, but at least the black hole in this galaxy has now been officially confirmed, basically making this unusual galaxy one of the most exciting objects discovered in the last 10 years. But I'm sure we'll be discussing this galaxy again, because even though it's no longer a record holder, due to its sheer size and its luminosity, It's one of the easiest objects to observe from these extreme distances. And so once the scientists learn something else, we'll come back and talk more about this in some of the future videos. Well, looks like we have another mystery coming from the James Webb Space Telescope. Yet another unusual galaxy with no explanation, new mysteries, and a galaxy that suggests that our current understanding and current models might once again be incomplete. And so, hello info person, this is Anton. Let's discuss this unusual galaxy you see right here that we've actually known about since 2010, but that was only recently confirmed to be somewhat strange. But before we talk about why this is strange, I think it's important to understand where this galaxy is located and why it makes no sense. So if we look at the image of the evolution of the universe, there's this period that we refer to as the Dark Ages during the first billion years of the existence. We've actually discussed this period recently because James Webb potentially solved the mystery of the Dark Ages, explaining what made it not dark. You can learn more about this in the video in the description. But during this Dark Ages period, we essentially had a lot of neutral hydrogen, gas that was very opaque to a lot of high energy emissions such as UV light. And so a lot of galaxies located in this region would very often have a very unusual light spectrum. They would sort of look like this. They would have what's known as a Lyman break, basically a sudden disappearance of anything in higher frequencies because UV light and everything beyond it completely disappeared. In more visual terms, it kind of looks like this. The galaxy is visible in the infrared, visible, and even near ultraviolet, but everything beyond that, it suddenly disappears. And we call these galaxies Lyman break galaxies because this basically happens at a very specific frequency, the Lyman break. The frequency where neutral hydrogen absorbs high energy photons. And so when we find a galaxy that has this unusual spectrum, we know it was very far away and was very likely extremely young. And so back in 2010, another survey discovered one of these galaxies whose name you see right here. Another Lyman break galaxy whose actual emissions for some reason were a little bit weak and a little bit unusual. Unusual in the sense that it was basically what's known as a quenched galaxy, or in other words, a dead galaxy. A galaxy that was no longer producing any new stars, and a galaxy that entered a period we usually expect from a galaxy that's billions of years old. Now we'll actually talk about quenching in a few seconds, but first, what exactly made this galaxy so strange? Well, first, the additional observations from the James Webb, specifically more recently, determined that this galaxy must have formed 700 million years after the Big Bang. In other words, it was not the first galaxy, but was definitely formed during the Dark Ages. And it had its most active period approximately 80 million years ago. But this active period only lasted for approximately 30 million years. And it seems to have completely ended 20 million years ago. In other words, this galaxy was only forming stars for maybe 40 to 50 million years, with something suddenly stopping star formation and making this galaxy quenched. A galaxy whose mass is actually not even that high, but whose mass should be enough to make it keep going and forming new stars for at least a few billion years. And so that by itself was a pretty big problem. It implied a problem with current models of star formation and galactic formation, but possibly some other problems as well. But first, let's actually talk about quenching. Quenching related to astronomy. It's essentially a process where a galaxy loses all of its cold gas that dramatically suppresses star formation or even stops it completely, turning a typical active galaxy into something more or less orange or red with practically no star formation inside. And based on a lot of observations, we've always believed that this is a relatively long process involving several periods of star formation and different types of galactic evolution. As you can see, our own galaxy, the Milky Way, is somewhere in the middle. And so this technically should take billions of years. But that's of course assuming normal conditions and assuming that nothing extreme happens to this galaxy. In some cases, extreme things do happen, such as the black hole, the central black hole, becoming extremely active and turning way too powerful for its own good. Now in most cases, a central black hole, when it becomes active, it will actually dramatically increase the activity in the central region, even encouraging star formation at some point. But in some cases, if the black hole becomes too active, it can start emitting such strong galactic winds, here we're talking about thousands of kilometers per second, that it completely strips the galaxy of its star-forming gas, making it become quenched within a relatively short time. But even here, normally this activity lasts for hundreds of millions of years or even billions of years because we've discovered a lot of different distant quasars that can easily do this for a long time. And so quenching a galaxy so quickly, within just 50 million years, is very strange. But alternatively, the star formation itself, through the process of very powerful supernova and a lot of fast-paced emissions, can actually create its own galactic wind as well. And so another way for a galaxy to be quenched is through a sudden, very explosive star formation period that basically removes all of the gas all at once in a relatively short time. But this normally is not permanent, and the star formation eventually returns as a lot of the gas escaping the galaxy comes back at some point. And it's also something we expect to last much longer. This might have happened in the center of the Milky Way sometime in the past, but it's also something that's definitely going to happen again as a lot of the gas gets reshuffled and creates new active regions. But another way for a galaxy to get quenched is through the interaction with something else. It's not uncommon for galaxies to become quenched as they get tidally disrupted or as they move close to a massive galaxy that strips them of all of their gas. This is usually through the process known as ram pressure. And so tidal disruption and ram pressure can also technically kill the galaxy. But once again, this is something that lasts much longer, and is also something that does not make sense here either. We don't see any partners, or at least partners that will be massive enough to suddenly strip the gas. And so instead we see a galaxy that's essentially right at the end of the galactic evolution, a so-called red sequence galaxy. Okay, a super quick lesson. When it comes to the galactic age and galactic types, astronomers usually divide them into blue cloud, green valley, and red sequence. These are the three main types we usually see in all of the galactic surveys. And we think that all galaxies start as these star-forming blue galaxies. In essence, galaxies filled with a lot of really young, really bright stars that produce a lot of bright ultraviolet light and extremely powerful emissions. But then at some point, as they mellow down, or as something else slows down the star formation, they eventually transition into the so-called green valley. Not green because they're green optically, but green because of the way that their color appears in the ultraviolet spectrum. And interestingly, this is where Milky Way and the Andromeda are technically today. They're not really dead yet, in other words, they're not quenched, but their star formation has dramatically slowed down, with both galaxies only forming like 1 to maybe 2 solar masses per year. And so they're definitely very mild compared to a lot of other galaxies. And if left alone, eventually they'll turn into red sequence. Galaxies like M87, the one with the picture of a black hole, a red sequence galaxy with barely any star formation and a lot of ancient stars. And these galaxies do actually appear a little bit more red in color, mostly because the stars here are normally red and orange. There are practically no blue stars on the inside because there is no star formation. But Milky Way and the Andromeda are expected to collide in the next 4 billion years, and so their colors are probably going to transform and the galaxies are probably going to become blue once again. This is going to take a while, but it will most likely happen in the next 5 billion years. Yet intriguingly, this newly discovered galaxy seems to be already red sequence. In other words, its emissions are extremely similar to what we observe from a quenched galaxy, usually billions of years old. Although here the observations from the star formation do suggest that this is a new galaxy. So it was born as a blue galaxy, potentially skipped its green stage, and became a red sequence almost right away, during the period when most other galaxies were extremely active and were producing a tremendous amount of stars everywhere. So yeah, something here is definitely strange. And even in terms of gas composition and overall appearance, it's surprisingly similar to our neighbor, the Small Magellanic Cloud. And the reason this is actually really intriguing is because we know that SMC, the Small Magellanic Cloud, is technically a primordial galaxy. It contains a lot of ancient undisturbed gas and was probably completely untouched by anything for billions of years until for some reason it came way too close to the Milky Way and the Large Magellanic Cloud and now suddenly exploded in star formation. And so here we do observe a lot of gas that's billions of years old that's suddenly forming a lot of new stars. And so in some sense, there's a really big chance that maybe SMC started in an extremely similar way. It got quenched really quickly, stayed inactive for a very long time, and now reactivated because of the interaction with some of the nearby galaxies. And that's maybe one of the hints we're getting out of this. It could be some kind of a common phenomenon where galaxies basically just pause star formation for some reason, restarting it once again once the proper conditions are met. Or on the other hand, maybe this is actually an extremely common phenomenon because in the past, researchers observed other galaxies temporarily stopping star formation as well, just to restart it later on. And so this temporarily quenching could be actually everywhere, it's just we've never seen it before in such an early galaxy. Most of the previous discoveries were in much more massive and much older galaxies. And so for all we know, this galaxy is also going to come back to life, either by itself once the gas returns into the center, or maybe once it experiences an interaction with some kind of a neighbor. But because of the unusual parallels with the Small Magellanic Cloud, it would be interesting to investigate what happened to the SMC back in the days, and what exactly made this galaxy quenched or quiescent back in the days. And so at least for now, definitely a somewhat intriguing discovery, and a discovery of a new record holder. The farthest quenched galaxy ever seen. A galaxy at a redshift of 7.3, or roughly around 29 billion light years away from us. It's been quite a long time since we've discussed ring galaxies. These somewhat mysterious galaxies that seem to be all over the place, that usually possess unusual ring structures that are somewhat difficult to explain, with the most iconic one visible right here, known as the Hoax object. A ring galaxy that even today does not actually have a very good explanation. And what's even more intriguing about this image is actually what you see if you zoom in. This unusual ring galaxy has another ring galaxy inside of it, but at a much farther distance. And though this was discovered something like 70 years ago by Art Hoag, a very famous astronomer, even after 7 decades, we still have no idea how they form. And so, hello wonderful person, this is Anton. In this video we're going to discuss some of the recent studies about these unusual galaxies, mostly because they try to use statistics to solve the mystery of these galaxies, in the process discovering a little bit more about them, but still not actually providing us with very concrete answers. But I guess first, so what exactly are these galaxies and what makes them special? Well, quite a lot of them have been discovered in the last few decades, and they do come in different shapes and sizes, with some of them not even containing a ring as much as some kind of an elliptical shape around them. But there's one thing in common about all of them. These rings usually contain relatively young stars. It's once again best visible right here. Here they contain a lot of massive, very powerful blue stars, only a few million years old, with the central region mostly being much older and usually very quiet. But even here there are usually a lot of individual differences. And when Art Hoag discovered this object, he actually believed that this was maybe a result of gravitational lensing. Or in other words, that this was some kind of an Einstein ring. And I mean, there is obviously some kind of a resemblance. But that's not really the case, because over the years, so many different shapes and sizes have been discovered, and it's definitely not an Einstein ring and not a result of gravitational lensing at all. With the obvious question being, how exactly are these produced, and is this something universal and extremely common? Well, today there are basically 3 major explanations. The first explanation involves a spiral galaxy, potentially similar to the Milky Way, possibly receiving a collision from a smaller galaxy that basically flies through it, which results in a lot of density waves, kind of similar to a rock falling into a pond. And this might result in these ring-like formations around a galaxy. And so for this galaxy, if this is what happened, it possibly happened at least 2 billion years ago. And though it definitely makes sense for some of the galaxies, like the ones you see right here that we usually refer to as collisional ring galaxies, it does not make sense for all of them, and especially for the Hoax object. There are no neighbors nearby and no signs of collision, and so obviously some ring galaxies, and possibly even most of them, are not produced by collisions. The second explanation involves the galactic bar, the massive structure in the middle that actually has a lot of gravitational influence on a lot of things inside the galaxy, and very often causes material inside the galaxy to move in a certain way. And so some spiral galaxies might experience what's known as bar instability, that suddenly throws off a lot of gas to the outskirts, which then forms overdensities thousands of light years away from the galaxy, with all these overdensities of gas suddenly forming new stars, producing these unusual ring formations. And though this is a really intriguing explanation, and once again makes sense for some ring galaxies, it does not apply here. Mostly because, once again, in the center here, there is no spiral, there is no bar. The nucleus of this galaxy is spheroid, and there's no way the ring could have formed in this way, with the third explanation basically involving gas from the outside. And here this gas might accumulate over time and kind of starts orbiting around the galaxy, basically forming a ring in a similar way that Jupiter and Saturn have rings. This explanation is referred to as galactic medium accretion. And so here, as this gas orbits around the galaxy and starts forming denser and denser rings, starts to eventually form regions to resemble typical molecular clouds, regions for star formation, and regions that potentially exist for several 100 million years. And in this sense, it actually kind of makes sense for one reason. These rings might form in a very similar way to a typical spiral. But instead of having spiral arms, here these galaxies just form a ring. Their formation history is somewhat similar, but they basically result in a slightly different shape. But just like with spiral arms, the star formation is the result of sudden overdensities and a lot of different shocks inside the formation. But these are just propositions and there is really no conclusive evidence. And that's of course the mystery. The mystery that astronomers are trying to solve. And we actually know that a lot of these ring galaxies seem to exist everywhere. But when it comes to such a perfect ring, only 0.1% of all galaxies seem to possess this. But in pretty much all of them, the ring is usually much younger. Only millions or hundreds of millions years old compared to billions of years old in the center. This is another famous galaxy we discussed previously, usually referred to as the Bursins galaxy. The link in the description talks a little bit more about this. But so far, based on all of the observations, the evidence points at different formation histories. For example, the famous Cartwheel galaxy is very likely the result of a galactic collision. The same is true of the galaxy known as AM 2026-424 and the galaxy known as ARP 147. Here you can actually see two different ring galaxies, with one just being the ring. And here it's what the astronomers refer to as the bullseye collision. Basically, a smaller galaxy passing through the center of a larger galaxy, causing the center to be disturbed and the outskirts to suddenly become very active. And this could be the explanation for most of the ring galaxies we observe today, but definitely not all of them. With one of the more recent studies from just a few months ago, basically discovering a somewhat large diversity of various galaxies out there. They've discovered approximately 1900 different ring galaxies, which represented 1/5 of all galaxies, and inside of these ring galaxies, 46% had an inner ring, 10% had an outer ring, whereas 20% had both inner and outer ring. Yet 6% also had what's known as the nuclear ring, or basically the ring inside the center of the galaxy, and 18% had what's known as a partial ring, which obviously means that they cannot be explained all in the same way. It basically implies that generally, when something really powerful happens to a lot of different galaxies, they sometimes, in approximately 1/5 of the cases, seem to form rings. And in this sample, only 64% of all of the ring galaxies had bars, which of course means that the galactic bar explanation does not apply to all of them either. But interestingly, most ring galaxies discovered generally had a much older stellar population, and they also had a much lower efficiency of star formation. Only stars in the ring formation were forming, whereas everything else was relatively quiet, basically suggesting that most of these galaxies seem to be kind of old and were potentially completely inactive prior to the formation of the ring. And so most of them are basically what's known as red sequence galaxies, also known as dead galaxies. Yet in contrast, they also had a lot more metallicity on average, or basically a lot of stars here were highly evolved and very likely the result of many different supernovae. Which I guess does imply that these are ancient galaxies with a lot of really old, highly evolved stars. But it also implies that these rings potentially cause some kind of a galactic evolution or even accelerate the evolution of galaxies, dramatically changing their elemental structure and even changing the physical properties inside these galaxies, making them extremely different from everything else. And so yeah, these are definitely super unique. But it was really this recent study that might finally lead to some major breakthroughs. This was a study that used a combination of AI and citizen science to basically discover a tremendous amount of ring galaxies once again. Here, using machine learning, researchers identified 400,000 spiral galaxies, with 30,000 of them containing rings. And by using a citizen science project known as the Galaxy Cruise, they then asked various participants from around the world to try to pinpoint various ring galaxies inside of all of this data, which led to 30,000 of them in total. 30,000 never before seen ring galaxies, representing approximately 5% of the entire data. And though none of them have been analyzed in detail just yet, this is a really important discovery, both for statistical reasons and because it might finally lead us to certain answers. Here, by comparing a lot of these galaxies, we may finally have some kind of an answer in the future. Right now there is still none, but there are some additional discoveries. For example, most of these galaxies seem to contain properties between spiral galaxies and elliptical galaxies. So maybe this is a transition stage or a result of some kind of interaction that changes one into the other. Likewise, even though most spiral galaxies were usually forming a lot of stars and were generally kind of active, in contrast, ring galaxies were not. They're basically referred to as green valley galaxies. Galaxies that are not dead, but are not forming a lot of stars either, even though quite a lot of them were really massive and contained similar properties to the Milky Way, with the last discovery being in regards to their location and interaction with much larger structures, compared to elliptical galaxies, which are usually found inside really massive superclusters, or spiral galaxies like the Milky Way, which are often somewhere on the outskirts. A typical ring galaxy was usually somewhere outside of a supercluster, or essentially, more ring galaxies tend to exist as you move farther and farther away from various centers of galactic clusters. And so basically you're unlikely to find ring galaxies in the vicinity of a group of massive galaxies, but you will find them somewhere on the outskirts or outside of this group, which implies that maybe ring galaxies can only survive in the environments where there's nothing to disturb them, which is generally also true for spiral galaxies as well. But apart from these initial observations, there's really nothing else we know about them just yet. They're still very mysterious, and there are still a lot of unanswered questions, and it will probably take years and years of additional observations in order to finally solve their mystery. And though some galaxies, like the Cartwheel, can be explained through collisions, explaining these perfect rings like the Hoax object or the Bursin galaxy is kind of challenging, and it will probably take just a little bit longer to finally figure all of this out. And I've actually been waiting for a final explanation for something like 8 years now. Some of the first videos I made about ring galaxies were approximately 8 years ago. And so I guess I'm gonna have to wait just a little bit longer. No explanations yet. And in this video we're going to discuss the discovery of an extremely unusual galactic jet that currently does not make a lot of sense. And that's because it's the largest galactic jet we've ever discovered, in some sense making this galaxy the largest discovered to date. And you see the simulation of this jet right here. And though it's not easy to see how big this is, it's actually 23 million light years from one end to the other. And that's of course the biggest such structure we've ever seen. Even bigger than the discovery we discussed only a couple of years ago in a galaxy referred to as Alcyon S. You can learn about this discovery in one of the previous videos in the description. But before we talk about the recent discovery, let's actually start with the mystery itself. Even today we still have no idea how these jets are produced. Okay, we maybe have some idea based on various simulations and based on very precise observations in X-rays, infrared and radio light, but these models do not explain some of these unusual anomalies discovered in just the last few years. Especially because in many cases there's just way too much energy produced here, with the material in these jets moving extremely close to the speed of light. And though the true mechanism is obviously unknown, we do have basic understanding based on a lot of observations with radio telescopes. For example, the observations from the iconic Event Horizon telescope, especially from some of the biggest and most powerful such black holes, such as the one you see right here from the Perseus A, definitively reveal extremely powerful magnetic fields based on a lot of polarization. And these magnetic fields must be formed by very powerful accretion disks. And so as a lot of matter falls into the black hole and starts to form the accretion disk that orbits around it, moving faster and faster and producing highly energetic interactions the closer to black holes they get, this also results in the production of magnetic lines. And that's because a lot of this inflowing matter is also magnetized, eventually producing an extremely magnetic, but also very compact, disk. But this disk becomes magnetically arrested. In other words, all of this magnetism is basically trapped. And though these lines do become trapped inside the disk, since the accretion disk spins around the black hole, these lines also become entangled. And so eventually these magnetic lines become so twisted and so entangled that they basically snap, overcoming the gravity hold of the black hole. And it's this unusual snapping process that potentially produces these humongous and powerful jets. But this is not a constant phenomenon, and to some extent is more akin to a kind of a broken engine producing puffs of smoke once in a while. Which is kind of what we actually see if we do zoom in on these jets and observe them in detail. We don't really see a constant emission, and instead we see a bunch of clouds moving at very high velocities. And so the evidence from Perseus A, the black hole that you see behind me, provided enough evidence to explain all of this. This black hole is spinning very fast, it has an extremely magnetized environment, which then results in relatively large jets. But not as large as the ones we're discussing today. And it actually beats all of the previous record holders by a huge margin, actually forming one of the biggest structures in the entire universe, and a structure that's kind of difficult to explain. And that's because when it comes to these radio galaxies, or these extremely long radio jets, scientists always believed that there was a kind of a limit, with the size limit basically being about 5 million light years. Mostly because with distance, these jets eventually fall apart as they start interacting with gas and a lot of additional material in the nearby intergalactic space. But Martin Oy and his team accidentally discovered a somewhat difficult to detect but still definitely visible 23 million light-year long galactic jet. This is the image produced in radio light. And just for a comparison, you can kind of see the Milky Way galaxy in the bottom right corner. And though officially this galaxy has a relatively long name, it's now also known as Porphyrion, officially making this the largest known galactic structure that beats the previous record holder, Alcyon S, that was actually discovered by the same person. And this was actually not the only such discovery. This was one of several different galaxies with really large jets discovered by this team, basically implying that this is not an anomaly and not an exception. This actually seems to be a regular process that occurs in a lot of galaxies that once again kind of violates the modern cosmological ideas. And obviously, we still believe it's produced in a very similar way through the entanglement of powerful magnetic lines. Right now it's unclear why it doesn't fall apart even after 20 million light years of travel, and why it still appears to be kind of straight. But one of the reasons we've never seen these galaxies before is because most of them are pretty far away. This one is about 7.5 billion light years away from us, when the universe was just half of its current age. And because we're seeing this when the universe was much younger, and thus a little bit thicker and a little bit denser, it actually makes even less sense. We technically expect much shorter jets in the much earlier universe, just because there is more gas and more matter to interact with. And so to produce something very straight and very long, you essentially need a lot of empty space. And here the only explanation that makes sense, and the one provided in a study, involves the cosmic web. The enormous structure and the enormous filament across the whole universe, where basically most of the galaxies reside. But between the filaments, there are these cosmic voids. You can learn more about this concept in one of the videos in the description, including the video about the so-called local void. But in essence, we know that this cosmic web connects the entire universe, and most galaxies, especially very massive, very powerful galaxies, are usually somewhere at the crossroads. And so it's possible that some of these jets are just pointed in such a way that instead of going into the cosmic web, they basically go into the voids. And so as long as the black hole is feeding constantly for at least several 100 million years or even a billion years, like in this case, it should have enough material to produce an enormous jet that's going to remain constant and straight as long as it's going through this void. And the only reason this jet is stable and does not dissipate with distance is maybe because it's in that void. Although in reality, right now this is actually one of the bigger mysteries. Nobody knows how it's able to maintain its strength and how it's able to maintain its relatively straight profile. But because this is not the first such discovery, it means that this is a relatively common phenomenon. phenomenon that appears to be the result of really powerful magnetic fields and very powerful black hole emissions that produce jets millions of light years in length, way above the official limits. But naturally, this also gives us just a little bit of a clue about the structure of the universe itself. And so here the researchers believe that this jet is about 66% the total radius of the void where this galaxy is located, which first of all shows us how big these voids were when the universe was only about 6.5 billion years old, while also suggesting that these jets maybe shaped the cosmic web as well. For example, here the scientists believe that they're also responsible for a strange increase in temperature discovered in various voids across the universe, and they can also explain certain magnetic interactions and certain magnetic fields that have been discovered inside voids as well. So basically this could be coming from these massive jets, it's never really been seen until now. And this of course means that this is maybe an extremely common phenomenon that ends up enriching these voids and even changing their properties, while also maybe affecting the cosmic web to some extent as well. But because these are very recent discoveries and because a lot of this is actually still kind of difficult to see, we're probably not going to know much more until future studies. Especially because this is really technically just the second such official detection, and so until additional observations with even more powerful telescopes, we're just not going to know much more. But right now the implication is that these extremely powerful jets very likely pump so many electrons and so many atomic nuclei into the intergalactic medium that they actually end up dramatically changing the distribution of matter around the cosmic web, possibly resulting in maybe different galaxies and different stars being produced in certain regions. Now that's just an assumption for now, but as you might have learned from one of the previous videos in the description, we know that powerful black holes and powerful quasars can actually dramatically shift everything around themselves, even killing all galaxies within several million light years away. You can learn about all of this in one of the videos in the description. But when it comes to these powerful jets or these unusually long structures, we'll definitely come back and talk more about this, most likely within the next few months. Well, looks like James Webb Space Telescope discovered yet another unusual galaxy. A galaxy that you can kind of see right here, that for the first time ever is showing us what's known as the Lyman alpha line, or basically a very specific emission of light produced at extremely faraway distances when the universe was only about 330 million years old. But why exactly this galaxy is doing this, and why this light is visible, is basically this new mystery. And so, hello wonderful person, this is Anton. Let's discuss why this is a mystery and what exactly this means, and at the same time, basically learn about a lot of these early galaxies and how they appear very different from any galaxy around us. But first, so what exactly is this Lyman alpha light, and why exactly is it important? Well, when it comes to very early galaxies, or essentially baby galaxies that just started forming, today we believe most of them were essentially what's known as Lyman alpha emitters, or they were basically emitting Lyman alpha radiation from neutral hydrogen. And this is a very specific type of light at approximately 121 nanometers in wavelength that's produced when the electron inside the atom of hydrogen transitions from one state to another. And specifically this is caused by a neutral hydrogen that was pretty much everywhere in the early universe, transitioning into ionized hydrogen when something acts on it, such as for example very powerful light from various star-forming regions. And so as a result, whenever we actually see this light coming from a galaxy, it usually implies at least two things. First, it means that this galaxy is located in a region with a lot of neutral hydrogen in the extremely early universe. And second of all, this galaxy seems to have a lot of star formation or some other means of producing powerful radiation, potentially containing some of the highest star-forming regions in the early universe that are actively reionizing regions around this galaxy, literally showing us the process of reionization as predicted by modern cosmology. But when it comes to these Lyman alpha emissions and these Lyman alpha galaxies, this particular emission line has never been seen earlier than 550 million years after the Big Bang. And that's because despite being super energetic and containing a lot of emissions, when looking at super distant universe, there's just so much neutral hydrogen everywhere that even this light does not get through. And so in most cases, what we usually see are essentially galaxies usually missing a lot of frequencies of light. For example, there's another type of a star-forming galaxy, known as the Lyman break galaxy, that will appear something like this. It's as if any photons that contain ultraviolet light, or even more energy, completely disappeared. And this is actually what it looks like if you were to look at this galaxy in different frequencies of light. Here's actually one example from JWST, a galaxy known as Uncover Z13. And this of course proves to us that this neutral hydrogen was pretty much everywhere for the first billion years, and made a lot of galaxies appear very differently. But extremely distant energetic galaxies, especially the ones containing a lot of star formation, produced very powerful emissions that eventually got through and possibly even reionized the rest of the universe. But because we actually expect more and more neutral hydrogen to exist as we go back in time, we obviously don't expect to detect certain types of light at certain distances. But this time researchers discovered something they once again did not expect at all. Here we have the 5th most distant galaxy ever discovered that seems to definitely possess an extremely bright hydrogen emission line that should be otherwise invisible. And unlike previously discussed galaxies that usually contain this Lyman break, with basically emissions of hydrogen practically invisible, in this case we definitely have a galaxy where the hydrogen emission is visible at just 325 million years after the Big Bang. And in this case it's seen as this really large line sticking out in all of the other wavelengths. And though at first it was not clear what exactly this shows us, because of the redshift, it was actually confirmed to be a hydrogen emission line of an extremely faraway galaxy. And once again, the reason this is unusual is because the universe was supposed to be opaque because of all of this neutral hydrogen. This line should not be visible. And so basically here, something in this galaxy is making all of these electrons drop down in energy and produce a photon of an extremely specific ultraviolet energy. And somehow all of this light got through this fog and reached planet Earth. And so detecting ultraviolet light at a redshift of 13 is currently not really easy to explain. Now the previous record holder was detected at a redshift of 7, so this is when the universe was about 600 million years old, but detecting it so early basically presents us with a new cosmological dilemma. The dilemma is so big that the scientists at first thought that maybe this was actually a mistake. This had to be confirmed several times, and we now have direct confirmation that this galaxy is indeed real and is indeed so bright at these very specific frequencies. One of the primary researchers, Kevin Heinlein, posted this image showing us what they were able to observe. Out of 19 observations using 19 different frequencies, here we're only seeing this in shortest wavelengths. And that of course proves to us that there is a lot of neutral hydrogen here and it completely blocks certain types of light. But even though it's brighter at longer wavelengths, it's still able to produce this bizarre emission. Lyman alpha hydrogen emission line that's unfortunately not visible in this image because it's actually right between two filters. And so even though there is no explanation for now, there are maybe some suggestions. Now the first and most exciting suggestion was that this was maybe the discovery of the mysterious population 3 stars, or basically the first stars in the entire universe. These stars would be very, very unusual, very bright, very powerful, and potentially create so much brightness that it could maybe shine through everything. But it's unlikely to be the case because here we don't really see other predictions, such as for example specific observations from emissions of helium. And so because we also see emissions from carbon, oxygen, and a few other things, right now this seems to be just a regular starburst galaxy. And because in this case the emissions themselves also seem to be slightly wider than usual, these broad emissions could be because of some kind of a really hot plasma or possibly some kind of a fast motion. So maybe things spinning around in the accretion disk, or maybe a lot of motion of gas inside some kind of a very powerful star-forming region. And so the only, I guess, not so satisfactory explanation right now is that this galaxy seems to be located inside some kind of a reionized bubble. The bubble that appeared extremely early on, as you see in this simulation, and produced a large volume around the galaxy that then somehow allowed this light to seep through to one day be visible from planet Earth. So essentially by being inside this unusual bubble, it prevented a lot of this light from being absorbed. But that's just one of the potential explanations, and right now there is really nothing else we have, except that this is a super unusual galaxy. A galaxy that will probably help us explain reionization a lot better, and help us understand the early universe a lot better as well. And so maybe Reionization just happened a lot earlier in certain locations and produced somewhat unusual and somewhat unexpected shapes or volumes of space that allowed some of this light to seep through and to be visible through all of this unusual fog. One of the main missions for the James Webb Space Telescope is to try to discover first stars in the universe. The so-called Population 3 stars that scientists believe existed billions of years ago and over time led to the formation of other stars that we usually refer to as Population 2. And because these first stars would be made out of pristine hydrogen, and because they could also get to extremely large and massive sizes, various types of models have already established what we should be seeing if we actually ever find these stars. Specifically here, we would be looking at regions with some of the hottest objects known to us, possibly at least 120,000 Kelvin and at least 50 solar masses. And these types of stars would also cause tremendous illumination of gas around these stars, forcing this gas to basically shine super bright. And well, it turns out that extremely recently, researchers might have actually discovered something super unusual in a galaxy far away. By once again conducting very detailed observations with the James Webb Space Telescope, scientists discovered the galaxy you see right here, GS NDG 9422. A galaxy at a redshift of 6, or essentially existing when the universe was only approximately 1 billion years old. But in this case, something was super unusual. The light coming from this galaxy was not really coming from stars. Turns out that most of the light in this galaxy is essentially glowing gas, similar to a typical fluorescent lamp. Something was causing the gas in this galaxy to glow super bright, much brighter than any star in it. And this was super strange. And almost right away, the initial assumption was that, okay, maybe we finally found them. Maybe this is actually the result of these first stars, or Population 3 stars, and maybe the James Webb Space Telescope finally discovered them. And well, hello wonderful person, this is Anton. Let's discuss this galaxy in a little bit more detail, find out what's actually happening here, or at least what we think is happening, but also let's start with a little bit of history. Let's go back 20 years. 20 years ago, when the telescopes were still not as developed, researchers got super lucky by observing something with the Hubble Space Telescope and discovered an unusual formation we now refer to as the Lynx arc. This was actually only detected because of powerful gravitational lensing effects, but in essence it revealed something super strange. It revealed what seemed to be the hottest known star-birthing region in the entire universe. The region at a redshift of 3.4, or when the universe was about 1.8 billion years old, and the region that seemed to contain millions of O-type stars with masses over 50 solar masses. In contrast, the nearest star-forming region with a lot of massive stars near us is right here. This is the Tarantula Nebula, and here we actually only have a few hundred similar stars. Some of the most massive and some of the brightest stars are all found right here. Yet the Lynx arc seemed to suggest something several thousand times more powerful and of course more massive. A region approximately 1 million times brighter than a typical nebula, and a region that was also much hotter than anything we've ever seen, which is why it was named the hottest region in the observable universe. Now we don't actually know what it looks like because it's kind of far from us, but this was an artistic representation. And well, back then this was assumed to be something that was very likely extremely common in a lot of these early galaxies. It was referred to as the furious firestorm of starbirth, a kind of a possibly short-lived stage where many different galaxies would suddenly become extremely bright and extremely powerful, possibly lasting for several million years. And though at first this was assumed to be Population 3 stars as well, it turned out to be something different. Here, an average star temperature was only about 80,000 Kelvin, which is, though much hotter than what we usually find in a typical galaxy, was definitely not as hot as Population 3 stars are expected to be. But this was still a really important discovery of the first super hot region, producing an enormous amount of ionizing radiation, very likely powering a lot of nearby nebula and causing them to have certain effects. And up until this point, this remained to be the only such example. But now the scientists discovered something that seems to be possibly even more extreme. The study by Alex Cameron and his team reviewed not just a single star-forming region, but the entire galaxy, where the gas from nebula outshines all of the stars. And this extremely strong nebular emission currently does not have a very good explanation. Now there are some explanations, but overall we basically have no idea what's really happening here, or which model seems to be correct. But the biggest question is, could this finally be the sign of these population 3 stars? First stars in the universe. Well, the researchers behind this paper don't believe so, and for really just one main reason. The overall spectral emissions, even though it seems to suggest metal-poor stars, still seems to come from stars of second population, because a lot of them show a lot of chemical complexity and various elements not expected to be present in the first stars. Nevertheless, these emissions are also different from a typical star or from stars we're usually familiar with. In other words, these are still exotic stars and can actually help us understand how galaxies transition from primordial versions to a lot of modern galaxies, or help us understand what happened in these early galaxies in the first billion years. And so after a several months long analysis, we now know just a little bit more about what's happening here. And so once again we have these really high temperatures, with very hot stars possibly 100,000 Kelvin in temperature, which is hotter than previously detected Lynx arc, but not as hot as population 3 stars, with a lot of these stars producing huge amounts of ionizing radiation that seems to power an extremely bright glow from a lot of gas in the galaxy. And weirdly enough, all of this glow dramatically outshines all of the stars in this galaxy and everything else around it. But obviously in this case, it was not entirely clear if it's actually stars doing this. One of the first assumptions was that maybe this was a central black hole that's basically causing all of the gas around it to glow super bright. And technically this is still one of the potential explanations, but the emissions coming from here don't resemble a typical black hole. Whereas other models trying to explain this using some kind of a reflection, or possibly some kind of a structure around the star, do not explain everything as well. But if this is coming from extremely hot stars, surrounded by a typical gas in a typical galaxy, a lot of the emissions seem to match the observations almost exactly. And so here we have a typical low density and low metallicity environment usually found in various nebula, but with ridiculously high temperatures, extremely likely powered by very hot, very massive stars, which basically results in the production of never before seen light spectrum coming from a distant galaxy. And so gas outshining stars caused by the stars themselves seems to be the best explanation, which of course confirms some of the earlier predictions as well. We expect early universe to contain a lot of massive hot stars in very large numbers and in somewhat tight arrangements, with many of these stars forming specific regions that would then cause reionization of the entire universe by producing enormous amount of energy. But as we know today, these environments can actually no longer exist just because the universe transformed so much. And so in the local universe, a typical hot massive star is only going to be about 40 to maybe 50,000 Kelvin as opposed to 100,000 detected here. And we're also unlikely to see millions of these stars in the same star-forming region like we see in this galaxy. But because this is the only such object discovered by the James Webb, it's assumed to be a relatively brief phase that's most likely going to stop within a few million years. But because this is also one of the predictions about population 3 stars, or potentially also explains why the early universe seems to be so different from the modern universe, because of studies like this, we're actually only getting closer and closer to various solutions in regards to the beginning of the universe, the formation of early stars, and the evolution of early galaxies. And so far, despite of these anomalous discoveries, everything to date kind of actually makes sense. And in this video, we're going to discuss a relatively recent discovery of yet another bizarre galaxy somewhere out there that currently does not make sense and potentially violates our previous assumptions about how galaxies form. And specifically, we're going to be discussing a discovery and a confirmation of a galaxy you see right here. Although in this particular image, it's kind of difficult to tell why it's unusual. But this galaxy, now referred to as Rebels 25, turns out to be a little bit unexpected for reasons we're going to be discussing in this video. But first, this is actually not coming from the James Webb Space Telescope. As a matter of fact, this really distant galaxy, at a redshift of 7.3, was actually discovered by the ALMA telescope, the networks of telescopes located in Chile. And so one of the surveys this telescope was used for is known as REBELS, which stands for Reionization Era Bright Emission Line Survey, a survey whose purpose was to discover extremely distant galaxies and very active galaxies present in the reionization period, or essentially in the first billion years of the universe. And here, unlike James Webb, ALMA is actually really good at detecting something else about these galaxies. Because of its sensitivity, it can actually look at a galaxy extremely far away and even detect minute motion, discovering how these galaxies move and how they rotate. And that's because this telescope is ridiculously sensitive, and today possesses a very high resolution. And while pretty much right away, it started to discover a lot of different galaxies, and the 25th galaxy stood out just a little bit. Here, this seemed to be a relatively active starburst galaxy, approximately 100 times more active than the Milky Way galaxy, or basically producing 200 solar masses per year, and a galaxy that was a little bit bigger than everything else in the region. Here, this galaxy was about 8 billion solar masses, which for galaxies at this time was a little bit too massive. But compared to the Milky Way, it was still pretty small. The Milky Way galaxy is approximately 1 trillion solar masses. So this galaxy was at least 150 times less massive. But here, it wasn't the mass that surprised everyone, it was actually the way this galaxy was spinning. When the researchers took a look at the redshift and the blue shift here, they discovered something they really didn't expect. Here they expected a massy early galaxy with stars moving in all sorts of directions, and instead, the motion here appeared to be extremely orderly, as if it was actually a rotating disk. And so this relatively small, relatively active galaxy appeared to be a disk galaxy, not so different from the Milky Way. Moreover, it wasn't just a disk galaxy. Here, it also seemed to show signs of some kind of an orderly structure, possibly even possessing spiral arms. And that, of course, did not make a lot of sense. And that's because, based on modern formation theories, we don't really expect galaxies to assume a spiral-like and orderly shape until they get at least a few billion years old. And so for a galaxy to develop orderly formations and to stop being so messy, it needs to evolve for at least a few 100 million years, possibly longer. But based on the redshift calculations, this was at a redshift of 7.3, or when the universe was only 700 million years old. And so by discovering a dynamically cold disk galaxy so early on, naturally researchers found themselves in a bit of a pickle. The pickle being that it's kind of difficult to explain this. Although here, a quick side note. No, this does not invalidate the Big Bang Theory, and it doesn't show us that the universe is much older than we currently believe. As a matter of fact, everything else in this galaxy seems to fit with expectations. This galaxy is 100 times smaller than the Milky Way, it's extremely active and produces a lot of stars, and is also producing a lot of extremely bright light. But here it's the shape and the rotation of the stars that doesn't really make sense. We expect this galaxy to be much more chaotic, and also be a lot more clumpy, but instead this galaxy is much more orderly, and from a distance seems to possess a relatively well-established disk, which just does not fit previous simulations and previous assumptions about galactic formation. As a matter of fact, previous assumptions established that for these structures to evolve, and to especially have a galaxy like the Milky Way galaxy, with a rotating disk and very neat structures inside, these galaxies would have to evolve for at least 2 to 3 billion years. Which means that when it comes to the shape at least, something here definitely doesn't add up. As a matter of fact, this is currently defined as the most distant, strongly rotating disk galaxy observed to date. And at first, when this was discovered a few months back, researchers were not entirely certain if their data was accurate. And so now this galaxy was also observed using additional bands or additional frequencies in order to confirm initial discoveries. And here these observations definitively confirm that this galaxy is really far away. It also seems to contain a lot of gas, very likely from various supernova, and is definitely young and growing fast. But once again, the shape and the rotation don't really make sense. On top of these new observations even confirm the development of much more complex features, such as some kind of a central elongated bar, and once again, potentially spiral arms. And so here the morphology is really the biggest mystery. But unfortunately, most of the stars here, and even most of the star formation, seems to be obscured by huge amounts of gas around the galaxy. And so the only way we can actually see that it's spinning is by observing the gas in the galaxy, which seems to be rotating in a somewhat circular motion. However, there is maybe one explanation here that doesn't break any theories. Here, this could technically be a colliding galaxy, where two merging galaxies are essentially merging in a way that makes it look like a disk. And so because a lot of the stuff here is hidden by all of this gas, and because this is also super far away, technically it could actually just be two merging galaxies. As a matter of fact, from observations of certain types of elements, there are definitely hints of some kind of a previous merger that has either just happened or has happened recently. But because of the distances, it's going to be very difficult to tell exactly what's happening until future observations with additional telescopes. Despite of this though, this galaxy is still a little bit unusual because it seems to be just a little bit more massive and contains a little bit more gas than it should, while still containing signs of complex morphology. And it's the fact that it could be a disk that's kind of difficult to explain. Although in one of the recent studies, the mass was discovered to be much lower than before. Either way, based on these observations and the conclusion from this paper, we can only assume that, well, these galaxies could potentially exist much earlier than we previously thought, and potentially can evolve into somewhat complex shapes much earlier using mechanisms we still don't understand. And so basically, instead of taking billions of years, it might actually only take 400 to 500 million years before the appearance of these complex shapes. But at least for now, this is just a preliminary conclusion based on these first observations from ALMA. Well, looks like we have a new record holder. A research team, whose paper you can find in the description below, discovered the most distant galaxy we've ever seen by using the iconic James Webb Space Telescope. The galaxy whose name and whose location you see right here, while also discovering another galaxy at a relatively similar distance and discovering why these galaxies exist so early on and what's actually happening here to begin with. And so, hello wonderful person, this is Anton. Today we're going to discuss a new record holder, talk about these early galaxies and what's happening inside of them, and I guess talk about whether this actually violates any of the known cosmological models, such as the famous Big Bang Theory. Although just to give you a bit of a spoiler here, the answer is no, not really. It's still good, everything here is fine. But what I wanted to start with is of course the video I made maybe a few years ago about the previous record holder we've discussed recently in one of the videos right there. This is the galaxy known as GNZ11, and this was the farthest galaxy we've ever seen. The galaxy that also possesses one of the most active black holes that you can learn more about in that video. But since the James Webb became operational, pretty much right away, researchers started to discover even more distant galaxies, with each new discovery beating old records. And a few months back, we've discussed this, JWST-Z13-0, a galaxy that was the most distant for at least a few months, and whose distance was confirmed by separate studies. Here this was a galaxy at a redshift of 13.2, and that existed when the universe was possibly only about 350 to 400 million years old. Although intriguingly, because of its unusually small size, and because it was kind of compact, one of the unusual propositions here was that maybe this was not the sign of a very distant galaxy, but instead a sign of what's known as a dark star, a hypothetical dark matter star that we've discussed in one of the other videos in the description. Either way, this was a really exciting discovery and a super exciting confirmation. And interestingly, if you convert this redshift to a physical distance, this is approximately 33.6 billion light years away from us. Now, I'm sure someone in the comments is going to ask, how is that possible if the light is only about 13.4 billion years old? And the answer is expansion of the universe. As things expand, they get longer and longer, and so the light from this galaxy traveled a much longer distance. But around this time, a lot of additional galaxies were discovered by other studies, with some even claiming galaxies that could be at a redshift of 17 or even higher, implying that they basically existed when the universe was much younger. But further analysis, especially analysis using spectroscopy, established that these galaxies just appear to be really far away, but in reality were much closer. And here's because the scientists, when they use spectroscopy, can usually establish direct distances with extreme precision. But by just looking at how red the galaxy is, sometimes we do get wrong results. And so basically, this galaxy was still a record holder for many months. It appeared to be the farthest, the most redshifted, with only one other galaxy even coming close. This was an object known as Uncover Z13, but it was probably just a little bit closer. But because many of these galaxies still lacked the spectroscopic confirmation, it was not clear if any of the other candidates were actually even farther. And well, it turns out that some were. And so this is pretty much coming from the same image, but of a different object. And here the redshift was established to be 14.32, or almost 100 million years before that other galaxy I showed you previously, implying that this potentially existed when the universe was only about 300 million years old, with the spectroscopy of elements inside this galaxy directly confirming the distance. And there was actually another candidate in this image as well, but this one might be just a little bit closer, despite the name suggesting otherwise. But one question you might be asking yourself is, okay, but how exactly do they know the distance? How can the distance be possibly so accurate? Down to a decimal point of the redshift. And here this is a really intriguing technique based on what we know about the early universe. If you've been on this channel long enough, you probably know that back in the days, and here we're talking about really back in the days, billions of years ago, the entire universe was covered in what's known as the neutral hydrogen. This is also often referred to as the Dark Ages, because during this time any kind of a high energy light, for example ultraviolet light or even X-rays, would actually strike neutral hydrogen, being absorbed by it, changing it into hydrogen ions, which basically resulted in a very strange phenomenon where a lot of light from various stars would only pass through this gas if it was not high in energy. So basically, if a typical star was emitting a lot of ultraviolet light, that star would be practically invisible. All of this neutral hydrogen would block its light until all of the gas around the star would ionize over time. And that's actually the period we also refer to as reionization period. It very likely lasted for several hundred million years until all of the hydrogen gas finally transformed. And because a lot of early stars were extremely hot, producing a lot of UV light, most of them were basically kind of hidden. Which also suggests that by looking at very distant galaxies, their light would look a little bit different. Today we call these galaxies Lyman break galaxies because they all essentially possess an unusual drop in frequencies around the wavelength of a typical UV light. And that's because all of this hydrogen absorbs the light after this, only letting certain wavelengths through. And we know the exact frequency for this because it's usually referred to as the Lyman break. And well, by knowing this frequency, you can then start measuring exact distances to a lot of super distant galaxies by looking at spectroscopy of those distant galaxies, which is precisely what was done here. And here's that Lyman break for this galaxy. Basically here the Lyman break was redshifted as if this galaxy was at the redshift of 14.32. And there's really no other explanation other than this is a super distant galaxy whose light is being blocked by neutral hydrogen because it's in the early universe. With one of the studies in the description below going through exact details of how this was discovered by using the James Webb Space Telescope. But here the discovery was also surprising for other reasons, because these galaxies are super active. They seem to display evidence for extremely vigorous star formation, with all of those stars naturally producing a lot of ultraviolet light that's then shifted toward infrared visible to the James Webb. With this galaxy also being relatively large and actually really bright for a galaxy existing so early on. Although when we say large for a galaxy during this period, it's still just a fraction of the size of the Milky Way. With the main discovery in this case suggesting that all of this light is really produced by these active stars and not really some kind of a black hole in the center, as suggested by some other studies or as seen in other galaxies. So basically this is not a quasar, this is really just active star formation. But star formation happening at an extremely fast pace. And something very similar is seen in this galaxy as well. But obviously no one can explain yet how these galaxies are able to exist so early on, or basically 300 million years after the Big Bang, which was one of the initial puzzles first identified just over a year ago. As you can see in this particular image, there are actually a few galaxies that are really far away, and at least one of them, still a candidate, appears to be even farther. And so actually for many months, the researchers thought that maybe this too was a much closer galaxy and the initial redshift was calculated incorrectly. But by conducting additional observations by using a near-infrared camera and by using specific filters, they were able to remove all of the galaxies nearby, only leaving behind galaxies that were really far away. With all of this brightness basically coming from hydrogen, and even some of it coming from atoms like oxygen, implying that even enrichment of elements has already begun inside this galaxy. And here we basically have something like 500 million solar masses in terms of stars, with all of them extremely active and extremely bright. But these stars are pretty young. Most of them are just a few million years old, suggesting that all of this started very suddenly and basically all at once. And so that by itself already tells us that it doesn't actually violate modern cosmological theories as much as it basically presents a problem for modern theories in terms of galactic evolution. Or essentially this highlights that the models of galactic formations we currently use are most likely incorrect or incomplete. Galaxies seem to form very suddenly and extremely vigorously, and as another recent study discovered, can even acquire galactic bars much faster than we ever thought. Here this is a galaxy that's only a few 100 million years old, and it already contains a typical galactic bar. And so galactic formation seems to be a new mystery. It looks like modern simulations lack something, because whatever happened in the early universe was very fast, and all of these stars and all of these galaxies transformed much faster and much more actively than we ever thought possible. Here this is an idea known as rapid mass assembly and metal enrichment. But additional search in a lot of these images produced by the James Webb revealed no additional galaxies at farther distances, specifically at redshifts of 15 to 20. And so pretty much all galaxies in this image are extremely unlikely to be farther away. There does not seem to be any galaxy right now existing during a period less than 300 million years after the Big Bang. And so this is definitely a super exciting new record holder and an exciting discovery confirming what the scientists believe now for several months. Galactic evolution and star formation has to be reworked from the ground up, and modern computer simulations that usually tell us about how galaxies form definitely don't tell us the whole story just yet. In many previous videos, we've discussed a lot of galaxies that made no sense. A lot of bizarre galaxies that are either extremely rare, extremely unusual, or possess features that not many galaxies seem to possess. And although pretty much most of these galaxies do actually have a pretty good explanation, there are some galaxies that are still kind of difficult to explain, especially the ones that are extremely rare. And so, hello wonderful person, this is Anton, and today we're going to discuss the rarest type of a galaxy we've ever seen, because completely by accident, researchers just found another unusual member to this very small list of extremely unusual green galaxies. As a matter of fact, with this new galaxy, there are only 18 that have been discovered so far in the entire universe, and these galaxies are referred to as green bean galaxies. And so let's discuss this in a little bit more detail, but I guess let's start with a simple question. Why is it that we actually have green galaxies, but green stars are basically impossible? And in case this is the first time you're hearing this, yeah, green stars don't exist. I mean, technically there is a way to maybe make something appear green, but naturally the stars will never look green because of the black body radiation concept and the way things emit light as they get hotter and hotter. So, for example, stars that we refer to as red dwarfs, or even red giants, are usually about 3000 Kelvin, and they actually do appear red because in terms of visible light, they're mostly able to produce red light, but their main wavelengths are all infrared. Then, once you get to the temperature of 5000 Kelvin, technically you should be seeing yellow. But in reality, because a lot of other colors are mixed in there as well, these stars will mostly appear white, which is actually the color of our sun as well. Even though it's called a yellow dwarf, it's technically a white star. But no matter how you mix this, there's basically no way to produce just green light. But there is a way to produce blue light once the star gets really hot. And so we can have blue stars, we can have red stars, but anything in between will appear white. Okay, so if there are no green stars, why does this kind of look green? This is a galaxy known as NGC 5972, and as this Hubble image shows us, it does look kind of green, which basically means that something else is happening here, and green galaxies do exist. And though this galaxy is actually pretty well known, there are some galaxies that appear extremely green from a distance, and they actually created a bit of a mystery back in 2007 when they were just discovered. These were initially discovered by citizen scientists using the Galaxy Zoo project, where a lot of these unusual green dots were seen everywhere. And because they appeared very small, very round, and very green, scientists started calling them green peas. And so these green pea galaxies, or just pea galaxies, turned out to be real. They were observed by various telescopes, including the Hubble telescope and more recently the James Webb, and they've now been very thoroughly analyzed because we've basically had like 20 years to study them. And to date, approximately 40,000 such objects have already been discovered, which though might sound like a lot, actually is not, because here we're talking about billions of galaxies out there, and so out of billions of galaxies, only 40,000 were found. And so these objects are rare, and especially rare nowadays, but seem to have been much more common in the early universe. And so by analyzing the light coming from these galaxies, researchers pretty quickly worked out what's going on here. They're basically green because of all of the gas inside the galaxy in between stars that seems to be illuminated by an enormous amount of star-forming regions, basically making this galaxy kind of fluoresce. And so essentially we have a lot of stars forming really quickly, producing a lot of energy, producing a light that appears to be green because of ionized oxygen. And so all of the oxygen between the stars, usually present in very low densities, ends up producing these beautiful green emissions that make these galaxies glow in green light. And interestingly, this is actually the exactly same phenomenon that produces green aurora. And so this is also oxygen, located in low density environment, and so when hit by charged particles, it ends up glowing green. But in this case, these galaxies are visible as bright green dots just because they're also very compact, no bigger than 16,000 light years across, and are also not particularly massive. And so in some sense, this is maybe baby dwarf galaxies that are eventually going to combine with much larger objects. At least that's what the scientists think right now. Either way though, they are pretty rare and still pretty mysterious. But not as rare and as mysterious as this new discovery that was just made not so long ago. And in some sense, these galaxies kind of look like this. They're not round, they're not compact, they're actually really large, but also extremely green. Discovered in 2013, and now just to, I guess, make it as a kind of a naming convention, they're referred to as green bean galaxies. I guess because in general, beans are bigger than peas. And what's really interesting here is that these are ultra rare. Up until this recent discovery, there were only 17 known to us, out of billions of galaxies out there. But now we have 18. With this recent study that you can find in the description, essentially describing this new discovery, specifically discussing that one galaxy that was once again discovered by accident. And so what exactly are these? Well, even though they're similar to green peas, the actual source of greenness seems to be a little bit different. In green pea galaxies, all of the light is produced by powerful stars, but in this case, it seems to be the result of the central black hole, or basically an active galactic nucleus, AGN. And so in this case, the powerful lights, specifically X-rays, coming from the central black holes, seem to ionize gas located far away from the galaxy that then starts to glow green, with the gas itself possibly released by the central region or the galaxy itself millions of years prior, very likely as a result of some kind of a major burst or possibly a major star activity. And so in some sense, these are also known as quasar ionization echoes, or basically a type of a light echo, where the light is being reflected from various gas clouds, making those clouds very bright and sometimes make them appear like they're moving really fast. But because the colors in this case are very similar to green peas, it's also very likely oxygen once again that seems to make them green. And so in this case, when observing this new galaxy, here's roughly what it looks like. We have a central core and two separate regions over 100,000 light years away from the center that are both now glowing in green, which basically suggests that whatever happened here must have happened over 150,000 years ago, because the light from the central black hole is now hitting those clouds that seem to be about 150,000 light years away. And because the galaxy itself is now relatively quiet, we basically only get to see the echoes from previous activity. But it's really the rarity of these objects that's kind of surprising. There's actually only one such galaxy per every 1.3 billion light years in the universe. So yeah, these are super rare. and it's actually unclear why. Or I guess it's unclear why they exist. I mean, there are quite a lot of galaxies that have active black holes, and a lot of galaxies that have gas around them, but what exactly that makes these galaxies so special that only they seem to glow in green, producing such large objects? Oh, the one explanation is that maybe this is just an extremely rapid phenomenon, possibly only lasting a few thousand years, and all of this is going to disappear really soon, just to reappear in some other galaxy. Or maybe they are fundamentally different from other galaxies. For example, in some of these galaxies, the mass of gas seems to be at least 100 times higher than in all other galaxies. So maybe for some reason, they just basically kind of threw out huge amounts of gas that's now stuck somewhere outside of the galaxy. And with this galaxy being number 18, this is definitely a somewhat intriguing phenomenon. This one is now known as RGB-1, with a lot of other names being just a little bit more extreme. I mean, most of these have only been studied once, and so we don't actually know much about them or what's inside of them. But based on these spectral observations, the actual emissions seem to be mostly produced by oxygen once again, and so it's definitely coming from gas. And so maybe here all of this was just a result of super powerful black hole emissions that first released a lot of gas and then millions of years later started to emit additional X-rays, very powerful X-rays, that made all of this gas super bright. But that's obviously just speculation and there are no exact answers yet. Interestingly though, this is possibly a very similar phenomenon to the famous Hani's Voorwerp, a bizarre object discovered back in 2007 by a school teacher from Netherlands that basically ended up being named after this person, Hani van Erkel. And so here too, we have these unusual objects that are basically echoes with green light emitted thousands of light years away. And here's roughly how all of this potentially works. And so here the galaxy is possibly illuminating its own tail. But compared to the typical Hani's Voorwerp, many of which have been discovered in the last few years, here the emissions are dramatically higher, making the entire region glow green. And here we're talking about an object that's over 100,000 light years across, possibly even more. Either way though, still an exciting phenomenon and definitely an exciting mystery. But we're probably not going to know much more because additional observations have not been done yet. As a matter of fact, James Webb has not taken a look at any of these, and so we don't actually know exactly what's going on yet. And today we're going to discuss yet another unusual discovery from the James Webb Space Telescope. And yeah, once again it's galaxies. Galaxies that nobody expected, and galaxies that right now don't really make a lot of sense. But the question is, do these galaxies break any modern theories, and is there anything we're discovering that shouldn't really make sense? So let's discuss this in a little bit more detail, focusing on this new study by Menguan Xiao and his team that discovered unusual ultramassive galaxies in the first billion years, the galaxies that have now been nicknamed red monsters. But I guess before we talk about this discovery, let's briefly take a look at some of the recent discoveries from the last few months. Although here I just wanted to focus on some of the strangest discoveries. For example, recently we've discussed this galaxy that was only formed about 200 million years right after the Big Bang that seems to contain unusual brightness, indicating a frenzy of star formation. And because many stars here have been calculated to be at least 90 million years old, it means that all of this has been going on for at least some time. There's actually even signs of things like oxygen that basically suggest several supernovae have already happened, and a lot of dust and a lot of different particles have already mixed in, producing second-generation stars. But once again, this is approximately 290 million years right after the Big Bang, something that was previously thought to be maybe impossible. And since this galaxy also contains a really large halo of very young, very powerful stars that have been actively reshaping this galaxy for at least 90 million years, this was one of the first signs that essentially star formation and galaxy formation might have been extremely different from how we always imagined it to be. And specifically different from various simulations such as the famous Illustris project that showed us galactic formation and star formation as a much slower and a much more methodic process, essentially suggesting that galaxies form gradually and usually inside really large dark matter halos that slowly capture all kinds of gas and eventually forms gravitational instabilities that turn approximately 20% of this gas into various stars and eventually galaxies. This is basically the process you're watching behind me. And so these observations from the James Webb basically put a big question mark on this entire process, with a lot of findings from 2023 and 2024 challenging these previous assumptions. Because it looks like many galaxies actually form stars much more vigorously, and a lot of really massive galaxies in the early universe were potentially very efficient at building stars and growing extremely fast very rapidly. We've actually discussed some of these previous discoveries when we talked about little red dots and the discovery of unusually massive black holes, along with the galaxy known as JWST, the videos about which you can find in the description. And so in essence, in 2023 and early 2024, James Webb Space Telescope started to provide us with a lot of different evidence for these unusually massive, dust-obscured galaxies that were actually hiding huge amounts of star formation and really massive black holes. But one of the main questions that was basically asked here is, okay, so does this actually break some of the theories and some of the assumptions, especially the assumptions coming from the famous lambda CDM model? The model that explains the universe using the dark matter, dark energy, expansion of the universe, and the formation of galaxies using these dark matter principles. In other words, should we actually start rewriting some of the physics and potentially recalculate certain things? And that's basically what this recent study decided to focus on. They essentially tried to reveal unexpected discoveries using these unusual galaxies, mostly present in the first billion years of the universe, in order to see if something is up or if it's still okay, and we're just basically seeing something unusual, but not something that breaks physics. And naturally, for all of these studies, James Webb was absolutely perfect. It helped the researchers reveal a lot of hidden details in many of these observations, even though technically these galaxies have been previously visible to us even using the Hubble Space Telescope. And here the focus was on 36 massive dust-obscured galaxies with redshifts between 5 and 9. And specifically focusing on the James Webb Fresco program, the link about the survey is also in the description, that mostly uses near-infrared observations and the observations using spectrograph in order to measure extremely accurate distances and also stellar masses of various galaxies. With one of the first discoveries being that, well, looks like, the star formation in many of these early galaxies was extremely efficient, much faster and much more vigorous than previously assumed and previously simulated. And that of course does actually challenge some of the galactic models. But the main focus was on 36 galaxies, where previously researchers only actually had ultraviolet data, and their actual distances were not yet confirmed. And specifically because with a lot of these galaxies, some studies and of course some videos on YouTube basically claim that many of these discoveries kind of break the modern physical models, including lambda CDM. And especially because so many of them have been discovered at much farther distances than we ever thought possible. But one of the first discoveries from this study is that there does not seem to be any tension with the models we have. Or basically these observations are kind of in line with what's really expected. And remember, this is based on some of the most accurate, most extreme observations we have to date. Out of all of these 36 galaxies, even though they're a little bit unusual, they don't really break anything. And to make the point even stronger here, researchers focus on 3 main galaxies, the 3 giants, 3 ultra-massive galaxies, actually even more massive than the Milky Way, that seem to be forming stars super vigorously, at least twice as much as expected. And here the surprise is that they seem to be just really efficient at forming stars. Approximately 50% of all of the mass seems to be converted into stars instead of being thrown away into the outer galaxy. And it's really this efficiency that's actually kind of surprising. Surprising compared to a lot of similar galaxies at similar distances, or galaxies much closer to us at much later times. So basically these 3 giants are so giant and so bright only because they are very efficient at converting mass into pure energy. At least twice as efficient, but possibly even more. And prior to this, all of the other galaxies usually displayed relatively similar efficiency and were not nearly as efficient. These galaxies really stand out. First of all, they do contain a huge amount of dust, which actually makes them very red in appearance. They're actually some of those unusual little red dots we mentioned previously, but because they're also much brighter, they're now referred to as the red monsters. Monsters that are even technically visible in the optical light as well. But the main focus here was to try to calculate the most precise distance and the most accurate stellar mass measurements, essentially highlighting how extremely accurate some of the observations from the James Webb really are. But once again, this is a really important side note here, none of these observations conflict with modern predictions or modern theories when it comes to the standard cosmological model. The only thing that seems to be in conflict here is the idea behind galactic formation and the efficiency of star formation in a lot of these early galaxies. And so because here we seem to be finding way too many of these really bright, really massive, really powerful galaxies, that's of course the new question. Why? There seem to be some unique processes at work here, and they seem to allow these galaxies to form stars super quickly, but exactly what's responsible for this is currently unknown. It's just a little bit more clear now that early universe was very efficient and produced a lot of stars and many different massive black holes. Something that older predictions could not anticipate, and something the simulations could not show us either. And interestingly, these unusual massive galaxies also seem to actually account for close to 20% of all star formation in the first billion years of the universe. So essentially, a lot of star formation was usually in these very bright, very massive, very concentrated galaxies that became so bright and so powerful that we can actually still see them today. But once again, why? So one of the potential explanations here is that maybe there is some kind of a supernova feedback that we still don't understand that basically causes a lot of star formation in many of these early, really dense galaxies, because many different supernovae start to go off one after another, which basically causes some kind of a chain reaction, forcing new stars to form quickly, go supernova again, and repeat the process over and over. Now this is just an assumption for now, and this is based on some of the interpretations from this study. We obviously have no evidence. But the other potential explanation is that maybe these central black holes play some kind of a role in this as well. Specifically, maybe these active nuclei, or these active black holes, contribute to star formation in some kind of an unusual way. So basically, if we find a galaxy with a really massive, really powerful black hole, especially in the early universe, it seems to somehow encourage the star formation as opposed to extinguishing stars, which is usually what we see in a lot of different black hole systems in the universe today. Likewise, maybe there's something else going on here, such as contributions from mysterious dark matter, dark energy, or something else entirely. Maybe it's all about very powerful magnetic fields, which many of these galaxies very likely possessed. And so right now there's really no clear picture and no clear explanation, just a lot of evidence that many different galaxies early on were super efficient. And efficient at both producing stars and producing massive black holes. But when it comes to breaking physical models, and especially the dark matter, dark energy, lambda CDM model, right now we seem to be kind of fine. These new observations still fit the model, and the researchers once again find no tension with anything. So yeah, the Big Bang still stands, dark matter and dark energy still seems to exist, and yeah, you probably have to go to work or to school tomorrow. So basically nothing changes here. And today we're going to discuss the iconic galaxy you see behind me. The galaxy that's often referred to as the Sombrero galaxy, that's more officially known as M104, or NGC 4994. A somewhat peculiar galaxy, approximately 31 million light-years away from the Milky Way, that despite being similar size and similar mass to the Milky Way, seems to possess an entirely different shape. But more importantly, extremely recently, James Webb Space Telescope was finally able to capture some of the more detailed images of this galaxy, discovering new secrets and presenting us with a few new mysteries. And so let's discuss this galaxy and the discoveries in a little bit more detail, but I guess let's start with the facts. So here's actually what this galaxy might look like if you were to try to capture it with a telescope. This is of course the image in the optical light, and so because of this bizarre, flat shape, over time it just became known as the Sombrero galaxy. But this bizarre head shape is actually formed by two very specific features. Features that are somewhat unusual for this type of a galaxy. Although here it's a little bit easier to see all of this if we look at the image from the Hubble telescope. And so here we have an extremely bright center, or basically an extremely bright nucleus, with an unusually large central bulge, but also this very strange flattened dust lane that seems to form an outer layer of a disk. But because we're seeing this from basically almost the side view, it essentially appears like a kind of a hat-like object. And one of the first mysteries here was basically trying to classify this galaxy or trying to figure out what shape it forms. At first it was believed to be maybe a spiral galaxy similar to the Milky Way, or at least some kind of a disk shape like you see right here. But some of the first observations in the infrared light with the Spitzer telescope revealed that it was definitely not. First of all, it showed us that it seems to have a very unusual ring shape around it, basically formed by a dust lane approximately 100,000 light years across, and a dust lane that forms an extremely symmetrical ring around the galaxy. But second of all, it also seems to possess a relatively large halo, somewhat similar to elliptical galaxies, like the one you see right here known as IC 2006. And so here it almost looked like some kind of a combination of several types of galaxies all at once. Or it was basically kind of like having an elliptical galaxy, but also mixed with the ring galaxy, such as the famous and mysterious Hoax object. You can learn about this galaxy in one of the videos in the description. And actually, in reality, it does seem to possess a lot of similarities to many of these ring galaxies, as opposed to similarities to the Milky Way. So in this case, just like with the Hoax object, here the center seems to possess basically no star activity, whereas the outer ring seems to contain a lot of atomic hydrogen and a lot of different types of gas, and also serves as a primary site of star formation inside the galaxy. You can actually see in a Hoax object here, the blue light indicates star formation, whereas the yellow light in the center, these are actually ancient stars, with the center itself being somewhat inactive for a long time. And so in some sense, this is possibly something extremely similar and potentially is a ring galaxy, just observed from the side. And so in some sense, this could be the closest ring galaxy to us and might even help us solve the mystery of their formation. But the mystery does not end there, because the center here is also kind of mysterious. So first of all, as I mentioned, there doesn't seem to be any star activity in the center, but there is a supermassive black hole, or technically an ultramassive black hole, because previous studies that measured the motion of stars in the center established that it's at least 1 billion solar masses, but possibly as large as 9 billion solar masses, making this one of the most massive black holes known to us, something like 2,000 times more massive than the one in the center of the Milky Way, but also surprisingly completely inactive, which by itself is kind of bizarre. And that's because the second farthest black hole, or the second farthest ultramassive black hole, the one in the M87 galaxy, is very active and produces a lot of energy, which is also of course what we're kind of seeing right here in the image from the Event Horizon Telescope. Yet the Sombrero galaxy black hole is potentially just as massive, but doesn't seem to do anything. It seems to produce some energy, and seems to be a source of very weak ionizing gas, but that's about all it does, which is kind of difficult to explain at the moment. But its mass, and of course the amount of stars in this galaxy, actually do suggest a lot of previous collisions, and collisions with a lot of massive galaxies, which is also reinforced by the idea that this galaxy, unlike other nearby galaxies, contains a huge number of globular clusters. Here we're talking about structures with thousands and even millions of stars, very ancient and very compact in size, that very often come from other galaxies and sometimes even represent ancient cores of different galaxies. And so in this case, Sombrero contains up to about 2,000, and that's at least 10 times more than the Milky Way galaxy. And here it's not entirely clear why, although in previous studies researchers suggested that it might be connected to the enormous bulge and the enormous black hole, mostly because there's a correlation between the size of the bulge in a galaxy and the total number of globular clusters. But a lot of these discoveries were made previously using other telescopes, and now for the first time ever we also get additional observations, very detailed observations, by the James Webb. And here's essentially what this image looks like. And though similar, it is very different. For one, it's extremely detailed and allows us to see things that were previously invisible. And here's actually how the three images from the Hubble, Spitzer and Webb compare to each other. And so even though the Hubble telescope presented us with a very bright, but also somewhat dusty galaxy, the images from Webb remove all of this dust and finally allow us to see what's inside. Most of these new observations were done in the mid-infrared, which highlights the details in the outer ring and brings into focus a lot of different dust that nobody knew was even here. And so one of the main discoveries in this case was basically a discovery of a lot of unusual clumps, and here we're talking about clumps of different types of gas and different types of molecules that are usually the building blocks for a lot of different objects in a galaxy that seem to be present inside this ring. And you can easily see them yourselves if you zoom in on the image, because they're basically visible as these individual bright dots that seem to be orbiting around the galaxy. And so these very strange, clumpy dust patches have now been studied by James Webb, revealing what's inside of them. Surprisingly, there are a lot of carbon-containing molecules, including polycyclic aromatic hydrocarbons, which represent a group of organic compounds, very often fused into rings, which sometimes resemble this. And the thing is, they're usually associated with a lot of star formation and even formation of new exoplanets, because they seem to be usually formed inside various nebula, which then, in the right conditions, start forming new stars and lead to new star systems. But despite containing so many different clumps, surprisingly, Sombrero Galaxy does not produce enough stars. As a matter of fact, the thorough analysis of star formation revealed that this galaxy seems to form at least 10 times less stars than galaxies similar in mass. And it even seems to form less stars than our own galaxy, the Milky Way, which kind of confirms the very strange nature of this galaxy, and even suggests that this is possibly one of the strangest types of galaxies in the vicinity of the Milky Way, and that means we have to study it even more. And that's combined with the fact that it contains so many different globular clusters, such a huge central black hole, a very bizarre ring, clumps of star formation that don't even seem to form that many stars, and possibly a lot of other mysteries that we still have not discovered. And so hopefully some of the future observations with some of the other telescopes, including the Event Horizon Telescope, can possibly explain some of these mysteries. But for now, it really looks like this is maybe some kind of a ring galaxy, similar to the mysterious Hoax object, except that this time extremely close to our galaxy, essentially in our neighborhood. And that's really because of these observations from the James Webb. Here, this ring is just a little bit too smooth to be anything else, and is very different from what we expect from a disk galaxy. Which means that we'll definitely come back and talk more about the Sombrero Galaxy in some of the future videos. And today we're going to discuss UFOs. Okay, I got you. Not the ones with aliens. In this case, UFOs actually refer to a really intriguing type of a galaxy that was only discovered a few years back. And in this case, UFO stands for Ultra-Red Flattened Object, and only discovered by the James Webb Space Telescope. And so essentially, we're going to be discussing yet another unusual mysterious type of a galaxy uncovered by the James Webb. But I guess here, let's start with the actual picture, which kind of explains why they're called UFOs. And so here we have the observations from the Hubble Space Telescope that basically reveal nothing, and the much more recent observations from the James Webb that suddenly reveal an unusual red flattened object that also kind of resembles a saucer, which is why almost right away many astronomers started to refer to them as UFOs. And this wasn't just like one or two galaxies, a huge amount of them was actually discovered all over the place, all completely invisible to the Hubble Space Telescope, but then suddenly appearing as these really bright red objects to the James Webb. Here's a bunch more examples from just the last few months, basically showing you the same phenomenon over and over. And naturally, this was a huge surprise. Not only was it difficult to explain what's really happening here, it also created a bit of a problem for the previous assumptions in regards to the number of galaxies in certain regions of the universe. Because here this meant that even in the much older universe, even though we actually expected nothing to exist there, there was a bunch of invisible galaxies that were previously completely ignored. And in this case, they all seem to be kind of similar. All of them were somewhat large, unusually spatially extended or basically stretched, but all extremely red and predominantly visible in the infrared, almost completely invisible to a regular telescope. And even for the scientists using the James Webb, this was a huge surprise. Because here the assumption was that since James Webb is able to see much farther away, we're only going to be discovering new galaxies at these super extreme distances, which naturally it's also discovered. But in this case, nobody thought we would find galaxies much closer to us when the universe was already 3.5 billion years old. And so here we had these massive red galaxies suddenly appearing out of nowhere. And like I mentioned, a lot of them, way more than anyone expected. And here's how they compare to a typical galaxy visible at a similar distance. And the first discovery was reported in this study from the August of 2022. And so here, Erica Nelson and her team basically discovered all of these galaxies completely by accident. But back then they were just referred to as HST dark galaxies, or essentially galaxies invisible to the Hubble Space Telescope. But unofficially, everyone called them UFOs. And in most cases, they were not that far away. The redshift here was about 2 to 6, so basically when the universe was anywhere from 1 billion to approximately 4 billion years old, with the first analysis revealing that basically they were just galaxies covered by a huge amount of dust, with this dust blocking most of the light and only allowing infrared light through. So essentially here we were just looking at very red, very dark galaxies. Or I guess more like huge dust clouds resembling galactic shapes. But to the infrared observations from the James Webb Space Telescope, these galaxies were extremely bright. They basically stood out right away and were visible in practically every single image, with all of them revealing very similar features. All of them were kind of similar in mass to the Milky Way galaxy, so already quite massive and quite developed, but all undergoing huge amounts of starburst activity, forming approximately 1,000 times more stars than the Milky Way, potentially representing some of the most starbursty galaxies during this time, basically producing most stars during the first few billions of years, but also, for some reason, covered in dust. And like a lot of dust. Up to 100 times more than in a galaxy like the Milky Way. And while at first it was assumed that maybe these are actually progenitors to some of the most massive elliptical galaxies, such as the famous M87. Even today, we still have no idea how a lot of these galaxies formed, and why many of them are so ridiculously massive, and are also shaped in such a weird way. But this was just an assumption based on the amount of stars these galaxies were forming. But now, after 2.5 years, we have an additional study from a similar team by Justice Gibson and Erica Nelson that basically analyzed these galaxies even more, making some additional discoveries. And so here, first of all, by using what's known as the JWST collaboration, which stands for JWST Advanced Deep Extragalactic Survey, here once again they discovered quite a lot of these invisible objects. But out of 112 of them, 56, or basically half, were classified as UFOs. And in every single case, they all possessed extremely similar properties. First of all, obviously more dust than any other galaxy, basically so much dust that all of the light here is covered entirely, with only infrared getting through. Here they basically compare it to a kind of a sandstorm inside the galaxy, making it practically invisible to a typical telescope. But also a lot of them actually seem to be very similar in shape to the Milky Way galaxy. Many of them had disks, they also had central bulges, and many of them were quite developed, except that they were basically once again invisible. With the only real mystery here being that, for some reason, they all contained a huge amount of dust. But where exactly this dust came from, or what became of these galaxies in the last few billions of years, that's actually the mystery. Because in the modern universe, in the last few billions of years, we see nothing like this. It's as if all of these UFOs only appeared for a few billion years and then transformed into something entirely different. So basically, one of the last UFOs potentially existed approximately 10 billion years ago. And here once again the existence of these galaxies was basically confirmed by looking at similar images from the Hubble Space Telescope and discovering nothing in the same location. Most galaxies were invisible, and only some showed just a little bit of red dust, which is basically what they would look like to us if we were to somehow see them in the night skies. They would just look like a very dark red cloud. But in this case, researchers also used computer simulations and modeling to try to understand what's inside these galaxies and what they look like in real life. And though most galaxies can be basically any shape, including irregular shapes, spherical or elliptical, for some reason UFO galaxies basically resembled the Milky Way. They were structured disks and were more or less flat. And because they all resemble typical spiral galaxies, once again, it's kind of unclear where all of this dust is from. Because if these were elliptical galaxies, there might have been some kind of an explanation, and even some kind of an evolutionary process that would eventually lead these galaxies to become galaxies like M87, really massive elliptical galaxies containing lots of stars and lots of dust. Yet that's not really the case. Here we have these very typical disk galaxies that even contain a central bulge that also resemble a typical starburst galaxy, such as for example NGC 5248 that you see right here, except that this galaxy we see really well, and it does not have the dust. Yet UFOs are unique in that they do look very similar, but they're just super dusty. And in comparison, one of the dustiest nearby galaxies is what's known as the Sculptor Galaxy. It's about 13 million light years away from us, and it does contain a lot of dust lanes that actually hide many different stars and different clusters from typical telescopes, and that only become visible to specialized telescopes like the James Webb. In contrast, there is also this. This is a discovery from 2023, and once again by the James Webb, and is one of the earlier galaxies that existed 13 billion years ago. And here this is not a UFO, but it's an extremely active starburst galaxy, currently known as Aztec 71, that's also extremely rich in dust, and basically implies that these galaxies were just extremely common in the early universe. Which means that these dusty galaxies were very likely just a common occurrence during the first 3 billion years. But once again, the mystery here is, what exactly did they become? Did they actually turn into one of the spiral galaxies, eventually losing all of the dust? Or something more exotic? And I guess more specifically, where did all of this dust eventually go? Because here we're talking about galaxies containing hundreds of times more dust than a typical galaxy like the Milky Way. Getting rid of this dust and turning it into something is definitely not an easy process. And so the only solution here is to find some kind of an intermediate state, possibly 5 to 6 billion years ago, which can possibly show us the process that eventually turned these dusty galaxies into something more familiar. But at the moment, there's just no answer, and even after 2 years of observations, this is still a really big mystery. We have no idea what these galaxies became or why they exist. But once someone proposes some kind of an explanation, we'll come back and talk more about this in some of the future videos. And today we're going to discuss some really strange discoveries about quasars. And to be more specific, this one quasar really far away from us, and I'm actually really glad it's so far, that seems to have completely killed all of the galaxies around it, even though we've never seen anything like this ever before. And so let's discuss some of these new discoveries in a little bit more detail, and of course talk about why this is important and how all of this connects to cosmology. But I guess first, a few more discoveries from just a few months ago that were actually also kind of exciting. First of all, extremely recently, researchers actually discovered the first ever quasar collision that seems to be happening during the so-called cosmic dawn. Basically the first 2 billion years of the universe. And this by itself was really exciting because it was always predicted, but just never seen. But unfortunately, it didn't really look like this at all. Instead, it looked like this. Barely visible, and resembling two red dots approximately 40,000 light-years away from one another. But because the scientists have now discovered this of course confirms various theories about galactic formation and galactic evolution, specifically evolution during the so-called era of reionization. Interestingly though, here there even seems to be a barely visible bridge of gas connecting both quasars. And even though in the last few years, scientists using various telescopes have been able to confirm a lot of different theories about quasars, in just the last few months they've also discovered some things that are somewhat difficult to explain. Although I guess just a super quick reminder. So in general, when we talk about quasars, we're really discussing very specific effects around supermassive black holes in centers of very specific galaxies. And so in those galaxies, these supermassive black holes acquire such a tremendously powerful accretion disk that it basically starts to change everything inside the galaxy. And so even though quasar is technically inside the galaxy and is also technically produced by the supermassive black hole, in reality it's actually the accretion disk and its effects that make quasars what they are. And so in one of these recent studies that examined the quasar you see right here known as SBS 1408 plus 544, researchers basically focused on the effects from the accretion disk and how it pushes the gas in a galaxy away from the black hole. And so here, by measuring the velocity of gas, they discovered that it was moving away at approximately 10,000 miles per second away from the central point. And so here, extreme pressure and temperature in the accretion disk, produced by the material in falling into the black hole, created so much friction around the black hole that this very hot, very bright disk produced ridiculous amounts of energy that instead now started to push everything away. And in many cases, the emissions from these accretion disks can actually be visible in pretty much every frequency, from radio light to gamma rays. But here, what made this observation a little bit unique is the fact that the wind was visibly accelerating as it moved away. Or basically, various gas particles in this galaxy were visibly moving faster and faster the farther away from the center they were, which all seemed to be the result of this very powerful radiation from the accretion disk continuously accelerating everything, basically blasting this galaxy completely apart. And these results, because they were collected over approximately 1 decade, with over 130 observations, were super accurate, which presented these accretion disks and of course quasars in a very different light from how we previously saw them. In other words, they definitely seem to be way more influential and way more powerful. But this very powerful galactic wind can also have somewhat opposite effects. In some cases, it can actually create pressure points, squeezing gas together and creating starburst formations, but in some other cases, it does the opposite. It actually completely eliminates star formation for millions and possibly even billions of years. And that's of course that new strange discovery from the most recent study on quasars, the quasar VIK J2348-3054, the object that existed approximately 770 million years after the Big Bang. So this is once again during that reionization period when a lot of quasars started to appear. But somehow this early galaxy has already acquired a black hole 2 billion solar masses. And that's of course one of the bigger mysteries. Now there are some possible solutions that you can explore in some of the videos in the description, but right now there is no exact answer. Either way though, this really massive black hole seems to be causing quite a stir in its neighborhood. Because it turns out that this black hole formed such an enormous accretion disk and created such a powerful quasar that it seems to have killed, or almost killed, most of the star-forming galaxies within approximately 16.8 million light years away from the quasar, which is absolutely ridiculous. Now remember, the Andromeda galaxy is approximately 2.5 million light years away from the Milky Way. And even here the distance between these two galaxies is relatively large. But here we're talking about distances that are at least 7 times as large, basically larger than the entire local group, in essence covering a really enormous volume of space. And the only reason this was discovered was because in this particular location, researchers expected an enormous amount of star-forming galaxies that display specific types of emissions. Scientifically, these are known as LAE, or Lyman alpha emitter galaxies, which is actually what you see as those red dots everywhere. And so on average, in most of the locations, researchers discovered a lot of these galaxies, even around certain quasars. But in this particular case, this quasar seems to have killed all of these LAE galaxies in a somewhat small volume of space in a sphere around the quasar, with any remnant galaxies essentially remaining dark and lacking any star formation. And if this was completely by chance, it would be extremely unlikely, according to the scientists. So here the quasar was definitely the main culprit. As a matter of fact, there are 38 star-forming galaxies much farther away, and even more if you were to zoom out and see this from farther away. But surprisingly, there's that one spot that seems to be completely empty and does not have any star forming whatsoever. And no other similar location is visible in any of the data. So in this case, this really seems to be some kind of a super unique, very powerful quasar whose galactic winds are potentially so strong that they basically blew everything away at a distance of approximately 16.8 million light years. Now because this is still in the early universe, chances are some of these quiet galaxies might start colliding and will actually have starburst activity later, but at the moment they're all super quiet, do not emit any star-forming radiation, and for the lack of better words, were basically killed. And interestingly enough, something very similar has been proposed before, maybe about the Milky Way and our neighborhood, and the very famous galaxy that we were kind of familiar with, known as M87. The enormous galaxy that kind of looks like this, but that became famous for the first ever image of any black hole from anywhere. This was taken by the Event Horizon Telescope and released back in 2017. And so this enormous black hole, potentially, once upon a time, billions of years ago, may have done something extremely similar. Here, this black hole is over 6 billion solar masses in mass, so at some point it could have been a quasar as well. And even though right now it's about 54 million light years away from us, several billion years ago, when this black hole was much more active, And when this galaxy was potentially a quasar, our two galaxies were also much closer. And so it's possible that back then, it might have had somewhat similar effects on the Milky Way, or at least to some extent. And though this is obviously just an assumption, by studying star formation in our own galaxy, and by measuring precise ages of various ancient stars, we could one day discover if there's any evidence for this, and if once upon a time, Milky Way was also basically killed and then resurrected when it started colliding with other galaxies. But at least for now, what this basically shows us is that quasars are absolutely ridiculous. So powerful that they can actually kill. These phenomena are so powerful, they can easily prevent formation of stars for millions of light years around the black hole, and thus have a tremendous effect on the evolution of galaxies and of course the evolution of the entire universe. But at least for now, that's all I wanted to mention. And today we're going to discuss some of the recent discoveries coming from the James Webb Space Telescope once again. And for the first time in a few months, we now have even more possible galactic candidates fighting for the record of the farthest galaxy we've ever discovered. In other words, in this recent study we're going to be discussing today, researchers potentially discovered 5 more galactic candidates that seem to have formed extremely early on. And so let's discuss this in a little bit more detail and talk about the potential ramifications when it comes to the modern theories, but let's also start with certain misconceptions when it comes to galactic distances. So the thing is, ever since James Webb became operational, there's actually been a lot of potential discoveries and a lot of potential candidates at extremely faraway distances. Here this distance is expressed in redshifts, which represents by how much the light from this galaxy is redshifted due to the expansion of the universe. And while early on there were quite a lot of candidates, with some as far away as the redshift of 16 or even 18. But when all of this started, so this was back in 2022, the farthest confirmed candidate we had was GN-Z11, a galaxy you can learn about in one of the videos in the description that was definitively confirmed to be at a redshift of 11. This is approximately 32 billion light years away from us, or in more comprehensible terms, when the universe was about 400 million years old following the Big Bang. But then within just 2 years there were so many new candidates, with over 700 discovered in just a few months. And though at first a lot of researchers were super excited, one by one, a lot of these candidates turned out to be actually much closer, with initial calculations just being not correct. Although here, let's talk about why they were incorrect and how this usually works. So normally, when trying to discover new galaxies, researchers point different telescopes at a certain spot and try to capture as much light as possible. And in some cases, they'll be able to capture extremely redshifted light from a lot of distant sources. But in order to confirm distances to these objects, especially because in this case this is just a preliminary discovery, scientists use at least 2 separate techniques. The first one is referred to as the Lyman break technique, or basically they look for what's known as the Lyman break galaxy. At these faraway distances, we actually assume this to be way before reionization period, and so the entire universe back then was covered in neutral hydrogen. And at those distances, a lot of neutral hydrogen would absorb anything in higher frequency, only allowing lower frequencies of light to pass through. And so for a typical faraway galaxy, the spectrum of light would look something like this. There would basically be a sudden drop-off, only visible in certain filters. And so by measuring the redshift of this Lyman break, it becomes possible to determine the approximate distance to the galaxy, although here the keyword is approximate. This is not a super accurate technique, with the second technique that usually goes hand in hand being known as photometry. And this is basically where you capture the same image in different filters just to see which frequencies get through. And so for example for this recent study, this is roughly what all of these filters resembled when looking at the same galaxy in different frequencies of light. And so here, as you can see, it's actually invisible in a lot of frequencies, but does become visible at certain point. And so this, in some sense, represents this Lyman break. And so basically, by comparing when the light from this galaxy disappears and looking at the redshift when this happens, researchers can then work out the approximate distance. But unfortunately, this only gives us a preliminary result. You can actually think of this as a kind of a rough calculation when it comes to galactic distances. So basically this is a way to identify if these galaxies are far or much closer. But in order to discover the exact distance, something else needs to be done, and something that's a little bit more complicated. That something is usually referred to as spectroscopic analysis. And this basically involves a detailed breakdown of light into individual wavelengths in order to then discover known frequencies of light from various molecules and from various atoms we're familiar with. And so here, by discovering certain molecules, which usually will have extremely specific frequency, it then becomes possible to determine the distance super precise, which by itself is great, but is also a much more expensive and a much longer technique compared to photometry and compared to rough measurements. And so only a handful of galaxies so far have been confirmed using this method, with the galaxy right here that we discussed previously, and this was in early 2024, officially confirmed to be the distance record holder. But nothing over redshift of 14 so far has been confirmed. Here, this redshift corresponds to the universe when it was only 290 million years old, or approximately 110 million years younger than the previous record holder, GNZ11. And though even from previous research, there are still some candidates left that could be pretty far as well, anything that was considered to be farther than this so far has been proven to be incorrect through this much more thorough spectroscopic analysis. So previously, as of November of 2024, the galaxy you see right here was basically a record holder. But in this new study by Kokorev and his team, researchers did discover something completely unexpected by using this beautiful cluster known as Abell S1063. A really massive galactic cluster that contains a lot of mass and a lot of dark matter that basically creates an extremely powerful cosmic lens. And this is of course how this phenomenon works. We have a really massive object between us and the target, and this massive object lenses the light so much that it magnifies faraway objects up to several thousand times. And so inside of this lens, researchers discovered several unusual galaxies that all seem to be located in the same area, but also all extremely dim. But more importantly, all of them were at a pattern redshift of over 15.9 up to about 18.6. And that farthest galaxy, with the redshift of 18.6, if confirmed, would basically exist when the universe was only 200 million years old, basically beating the earliest galaxy, JWST 14, by approximately 90 million years. But apart from just seeing these galaxies, there were some additional surprises. First of all, they seem to be in a relatively similar region, suggesting that there actually could be so many more that we're not seeing, and also suggesting that they basically all started around the same time. And more importantly, when looking at the density of galaxies in this region, there basically seems to be a small tension with previous assumptions and previous predictions compared to what we're seeing. So basically here the discovery suggests that there seems to be way more galaxies, very tiny, very dim galaxies, but all present in a relatively similar volume of space. And they all seem to be super young, almost entirely dust-free, and obviously contain very young star population. But when combining this result with previous results from additional surveys, it also becomes apparent that at a certain point, the number of galaxies drops dramatically. And so one of the conclusions from the study is that at a redshift of 17, or when the universe was 230 million years old, there seems to be a sudden and dramatic drop in bright ultraviolet emitters, suggesting that up to this point there were not a lot of galaxies, and then very suddenly they all appeared all at once. And essentially confirming something we've discussed relatively recently in one of the previous videos, that suggests that for some reason in the early universe, the star formation was much more efficient compared to the universe today. In other words, many of these galaxies suddenly appeared and became super bright and were producing a lot of stars very quickly, for reasons we still don't understand. And more importantly, if this discovery is confirmed, it actually also explains why so many of these bright galaxies were discovered at much closer distances, with a redshift of 10 to 14, because in some sense we're just seeing the progenitors that grew really fast and became super bright very quickly. But at a redshift of 19, there seems to be nothing, essentially suggesting that some of the first galaxies potentially appeared 200 million years after the Big Bang. And intriguingly, all of these discoveries basically violate nothing. All of the cosmological frameworks seem to directly agree with these discoveries, and potentially even explain some of the more unusual recent observations when it comes to galactic formation. But there is a very important side note that goes back to what I just mentioned about photometry and spectroscopy. At the moment, these discoveries were just made using photometry and the Lyman break, and not a more detailed spectroscopic analysis. However, in this study, researchers did actually model spectroscopy and compared it to some of the previous confirmed discoveries, which did help them to come up with a more accurate data. And so in some sense, these galaxies could be some of the farthest discovered, but until spectroscopy we're not going to know much more. But if these galaxies are as far as they seem, there is of course a really important question. What's making them produce so many stars so quickly, and how did all of this start?
Right now, the current explanations basically suggest one of three things. Maybe this is a result of some kind of a black hole feedback, and we know that a lot of giant black holes already existed back then. Maybe this is a result of some kind of a supernova explosion feedback, or a result of dark matter and dark energy bringing a lot of matter together, causing super quick star formation and a quick development of these galaxies. And so the new mystery is, why did stars form so differently and so much quicker in the first billion years when the universe was born? Which is of course entirely different from previous assumptions and previous simulations, including the recent release of the Frontier E simulation, which basically represents the largest and the most complex simulation of the universe ever created, which seem to create galaxies and seem to create stars in a slightly different manner. In other words, there's a bit of a disconnect between the reality and what we're observing compared to simulations. But we'll discuss this simulation and some of the discoveries here in a separate video. So, subscribe and stuff. But in essence, for now at least, that's it. Researchers discovered new, even farther galaxies, but we don't really exactly know how far they are until future spectroscopic studies. But if confirmed, because so many of these galaxies seem to be in the same location, and because they seem to be extremely prolific at forming stars, yet are actually all really small in size, this could potentially lead us to new explanations in regards to the formation of galaxies. And today we're going to discuss yet another unusual galactic discovery coming out of James Webb Space Telescope. A discovery of a galaxy visible in a distant universe when the universe was only about 600 million years old, at a redshift of 8.29. But what makes this unusual galaxy, now referred to as the Firefly Sparkle, kind of exciting, is the fact that this is the first time in history that we're able to observe individual tiny galactic parts as this early galaxy is being assembled, in this case allowing astronomers to essentially reconstruct the overall shape of this galaxy, discovering individual differences in various parts of the galaxy, and helping us visualize a galaxy that turns out might have been extremely similar to the early Milky Way. And so here once again we have a groundbreaking discovery from the James Webb, allowing us to see a super distant galaxy with a lot of detail. And so let's talk about some of this, focusing on how this was discovered and what we're actually seeing. But I guess first, let's get the important stuff out of the way. What we are observing in this galaxy right now seems to match directly a lot of theoretical predictions. And specifically predictions in regards to galactic formation and how large galaxies essentially got assembled from individual smaller pieces right in the beginning of the universe. And so what we're seeing here is basically a kind of a Milky Way-like galaxy progenitor that seems to be at least 10,000 times smaller and less massive. But despite being so small and despite being so young, it was captured in this image. And in this case, it's all because of this. MAX J1423, a really massive galactic cluster at a distance of 6.6 billion light-years away from us, that's essentially so massive that it produces an extremely powerful gravitational lens. And it was actually discovered and analyzed over a decade ago. And so due to these very powerful gravitational lensing effects, quite a lot of distant light becomes amplified, and in some cases by thousands of times. And it just so happens that some of these lenses produced a very strange arc, although technically these arcs are pretty common. But in this case, what made this arc kind of special is really the shape itself. It was basically stretched into a very long, but also relatively bright, sparkling line, which seemed to possess different colors inside. And well, almost right away, this turned out to be a really distant object, basically located in the so-called cosmic dawn, the early time in the universe when a lot of galaxies were still forming, a lot of gas was still neutral and prevented a lot of light from traveling, making most observations extremely challenging. And so in most cases, a lot of galaxies at these distances resemble tiny dots or tiny smudges, barely visible at all. Here's for example one of the previous record holders for the distance, the galaxy known as GN-Z11, at a slightly higher redshift of 11. And so here we don't really see any structure, we just basically see a kind of a smudgy spot. But here astronomers got a little bit lucky. Even though the light here traveled for approximately 30 billion light years, it actually produced a little bit more than a smudge, revealing individual shapes, and essentially revealing individual structures inside this galaxy, which could now be studied individually and compared to one another. And so despite the stretching and the bending from the gravitational lens, here astronomers reconstructed the shape of this galaxy, producing something that looks like this. And this is really strange. It's basically a kind of a teardrop-shaped galaxy that seems to contain 10 powerful star clusters, but in slightly different regions. 2 of the extremely bright clusters are sort of in the upper or the north part of the galaxy, whereas the 8 other clusters seem to be bunched together on the bottom, don't produce as many stars anymore, and are slowly forming in actual galactic shape. And so here we have a very strange bilobal distribution that for the first time ever shows us how a young galaxy potentially formed. But importantly, each one of these clusters seems to be at a very different phase of evolution and contains stars of different age. In other words, they all start at different times. And even more importantly, if combined together, these clusters seem to form at least half of the mass of this entire galaxy. And we even get to see some of the diffuse light from the surrounding stars. And so to astronomers, this is an amazing image. It literally shows us a physical process of a galactic assembly, something we've never seen before, or at least not so early on. But as you can see in this image, there are 2 more things here that are kind of exciting. 2 companions. One approximately 6,500 light years away, and one approximately 42,000 light years away. And so in essence, we're looking at some kind of a triple galactic system, where these 3 galaxies will most likely become one in the near future, essentially confirming another major hypothesis. Young galaxies very likely cannibalize each other, with only one eventually remaining. And so this growth by absorption is based on a relatively old theory. And so in this case, we seem to have found one of the progenitors. But in galaxies like the Milky Way, we do see the end result, because galaxies like ours contain hundreds of different globular clusters and a lot of tidally disrupted objects orbiting for billions of years. But this is very likely how all of this started. And interestingly, here we even have the total mass. Each of these clusters, for example, seems to be at least 100,000 to 1 million solar masses, with the entire galaxy being no more than 20 million solar masses in total. But surprisingly, a lot of these clusters seem to contain way more density and obviously way more stars and way more gas compared to anything we have today, which suggests a much more vigorous star formation and basically accelerated growth and development, something James Webb has already seen many times and we'll discuss in some of the previous videos in the description. But one of the reasons this is known as the Firefly Sparkle is really because this galaxy is currently bursting with star formation. It's growing super fast, and that's basically one of the main reasons why it's actually visible to us. Nobody actually believed we would ever see so much detail coming from such a distant galaxy, even from the James Webb Space Telescope. Yet here we are. James Webb was able to resolve an extremely distant galaxy, once again approximately 600 million years after the Big Bang, or at a distance of 30.1 billion light years, being able to see individual parts only tens of light years across. So this is literally the most detailed and the most accurate observation we've had so far from such a distant place in the universe. In comparison, here is a more recent image from the European Southern Observatory of a very similar cluster known as Massey 54, that's about 150 light years across, approximately 87,000 light years away from us. And so just the fact that we can see one of these objects so well, to me at least, is kind of mind-blowing. But even though this was just discovered, we obviously already have some really important findings. For example, one surprise here is that most of the mass seems to be inside globular clusters, or these very powerful star clusters that seem to represent up to 60% of total mass. In contrast, in a typical galaxy, globular clusters are usually just a fraction of the mass. For example, the Milky Way contains approximately 150 globular clusters, containing roughly 100 million stars in total. But the Milky Way itself contains 400 billion stars, so there is definitely a huge difference. Here though, in this young galaxy, it seems to be almost the opposite. More stars and more mass inside clusters, only some stars outside. At the same time, because we see different colors in these clusters, it suggests star formation was not simultaneous, but actually happened in different stages, very likely millions of years apart. For example, some of these blue clusters are very likely only a few 100,000 years in age and might have just started producing stars, whereas the older clusters, especially the red ones, could be millions of years old and potentially represent some of the first objects forming in this baby galaxy. But because in this case, the overall mass of this galaxy seems to match directly what we believe Milky Way was like back in the days, to scientists studying our own galaxy, this is a really exciting discovery. It really shows us what the Milky Way was like in the first few 100 million years after its creation, while also indirectly showing us the next natural step, the galactic cannibalism or absorption. And this time we're going to discuss something that we've discussed many times before, but looks like, yeah, there might have been a mistake. Not made by me, but made by a lot of scientists working with incomplete data. And so basically here, the title of this video is probably going to be something like, looks like we were wrong about the Milky Way and the Andromeda collision, because that's basically what the video is about. The collision between our galaxy and the Andromeda that has been discussed in many previous videos before, that many scientists believed would eventually happen, currently, based on some of the most recent observations, may not be so certain after all. And so in this video we're going to discuss some of these new discoveries, what this essentially means for our galaxy, and of course what's being proposed now. But I guess first, as always, let's start with a bit of a history. And mostly to help you understand why we always thought that these two galaxies are actually on a collision course. And all of this technically starts over 100 years ago. The American astronomer by the name Vastos Slipher was trying to examine Andromeda galaxy sometimes around 1912. And back then astronomers didn't even know galaxies actually existed. For approximately 2 more decades, most astronomers assumed that these galaxies were basically unusual nebula inside our own galaxy. So back then, astronomers thought that the universe was much smaller, sort of the size of a typical galaxy. And you can learn about this concept of discovering the entire universe in one of the previous videos in the description. And so while Vastos Slipher was looking at Andromeda, he noticed something very unusual. This peculiar nebula was actually blue shifted, suggesting that it was basically moving toward planet Earth at a relatively high velocity of approximately 110 km per second or 65 miles per second. And not so long afterwards, basically when we realized that these are galaxies, researchers realized that there's actually a very high chance that this galaxy at some point will collide with the Milky Way. But up until early 2000s, all of this was super hypothetical and extremely uncertain. But once we got the Hubble telescope, and once the researchers started to observe some of the stars inside this galaxy, they were able to collect various types of data in regards to the positions of stars inside this galaxy, in relation to various background galaxies, and everything else around the Andromeda. And by collecting a lot of data for approximately 1 decade, so basically between 2002 and approximately 2010, sometimes around 2012, several papers came out suggesting that our two galaxies, despite relatively large distances, seem to be on a collision course. This was discovered by analyzing thousands of different stars and the relative motion compared to galaxies behind them. But even though in this case the velocity toward us was pretty accurate, so approximately 110 km per second, it was still somewhat difficult to establish the lateral or sideways velocity. So basically here we knew that the stars are headed toward us, but would they also headed left or right? Or would they just headed directly for us? So that's obviously not something we could establish yet. On top of this, this was way before we discovered a lot of satellites around the Milky Way and the Andromeda, and so back then the knowledge of the so-called local group was actually kind of minimal. Here the local group basically refers to all of the local galaxies, including all of the satellite galaxies, of which we've actually discovered so many in just the last decade. As a matter of fact, some of the biggest discoveries and some of the most unusual galaxies were only discovered in the last 10 years. For example, galaxies like Antlia 2, which was not even visible until recently, was literally hiding in plain sight, with 2 more galaxies around the Milky Way discovered in 2024 alone. And because of various discoveries in the last few years, modern theories suggest that our galaxy potentially has several hundred different satellites, as opposed to just having like 5 or 6 back when these calculations were initially conducted. And this particular fact is going to be super important in just a moment. Either way though, following the initial assumption that these two galaxies are colliding, quite a lot of simulations, including this one, basically try to recreate what all of this might look like. And back then, the result of this collision started to be referred to as Milkdromeda, something that would possibly happen in approximately 5 billion years from now, with several studies even trying to predict what's actually going to happen to the solar system and planet Earth. Well, by then planet Earth would actually be super hot, so obviously there would be no life here, but the sun would still be around. And here the simulation suggested that either the sun gets kicked out from the galaxy, or it potentially approaches the inner galaxy, possibly even super close to the central black hole, which might even shred it apart. But obviously all of these were just assumptions, and as you're going to discover now, were probably completely incorrect. But galactic collisions in Andromeda and the Milky Way have obviously happened many times. As a matter of fact, in one of the most recent studies from 2023, researchers even found evidence for what seems to be a major galactic collision in the Andromeda that possibly happened just 1 billion years ago. Moreover, we've also discovered signs of recent collisions in the Milky Way, and we know that galaxies like Sagittarius dwarf spherical galaxy are currently colliding with the Milky Way as well. At the moment, not much remains of this galaxy, but it's still kind of there and it's still kind of visible. Alright, well, let's get to the point. So what about the Andromeda and the Milky Way? Well, now we get this recent study based on some of the most advanced observations, and it essentially suggests that the Andromeda-Milky Way collision may not actually happen at all, or if it does happen, it's going to be much later. And Till Sawala and his team came to this conclusion for one simple reason. The most recent and extremely accurate observations from the Gaia telescope that allows us to measure the motion of the stars super accurately, mixed with new simulations that didn't just include two galaxies in it, like the one that you see right here, but also included other masses around these galaxies, including some of the largest satellites. And so once these new simulations were ran, researchers realized that there's just way too much uncertainty right now when it comes to motions of some of these stars used previously, but also other galaxies, such as satellite galaxies, that definitely play a super important gravitational role when it comes to this collision. And so here, depending on the situation, these galactic collisions end up in a lot of different scenarios, with many of them resulting in no collision whatsoever. But approximately 50% do result in a collision, although in this case, maybe in about 10 billion years. Not 4.5 or 5 billion years as we previously believed. And yeah, by then, the solar system is definitely going to transition into something entirely different. And so in essence, in this particular study, the important addition was the so-called confounding factor, involving various gravitational effects of a lot of smaller galaxies that we definitely know exist everywhere around us. As I mentioned previously, there's possibly up to 500 tiny galaxies around the Milky Way, as suggested in one of the recent studies you can learn about in one of the links in the description. And each of these hundreds of galaxies provides an individual pool, slightly shifting the Andromeda and the Milky Way as they're headed toward each other. And because the current distance between galaxies is actually pretty far, 2.5 million light years away from each other, it essentially means that there's a high chance these galaxies are going to miss. So just to give you a visual example, right there on the right, that's the Andromeda, and on the left, that's the Milky Way. So they're still pretty far from each other, and are technically moving really slow. And since Andromeda is also highly influenced by the Triangulum galaxy, the M83 you see right there, this makes this trajectory prediction super challenging. And even if it does happen, it's definitely not going to resemble what you see right here. It's going to be way more complicated and involve a lot more galaxies. But at some point in the next few years, we might actually have our final answer. And that's because Gaia telescope is going to be releasing its new data, which will hopefully be enough to establish the exact trajectory of not just these galaxies, but also satellites around us. And though at some point, billions of years from now, we do expect all of these galaxies to basically become just one large galaxy, based on this new study, all of this might take much longer, possibly over 100 billion years, for everything to finally collide. But when it comes to Earth, and specifically life on Earth, we're definitely not going to witness any of this. Within the next 500 million years to possibly 1 billion years, the sun is going to become hot enough to basically evaporate oceans, potentially stopping the plate tectonics, which will very likely end most complex life on planet Earth. There might be some bacteria for like 1 billion years or so, but by the time these galaxies come even close to each other, all life will be extinct. And Earth, if it's still around and somehow survives the red giant stage of our sun, will eventually have its night skies transformed completely. And at some point, possibly in the next 100 billion years, it's going to resemble something like this. That's essentially when all of the galaxies combine into a large elliptical galaxy, which may or may not transform afterwards. But at least for now, looks like maybe Andromeda and the Milky Way might still orbit each other and potentially not collide for a much longer period of time than we initially thought. And so quite a lot of videos I made previously, I guess like 5, 6, 7 years ago, now essentially become, I guess, completely wrong. But that's the beauty of science. Sometimes you get new facts and you have to revise everything. And right now the observations and the simulations in this paper seem to be the most accurate. And today we're going to discuss some of the new discoveries when it comes to the formation of extremely large galaxies, and specifically the mysteries of their formation, because even today it's not entirely clear how some of these galaxies formed. And that's because in the last couple of weeks, there's actually been a couple of papers, with one potentially solving the mystery of elliptical galaxies, but one potentially discovering another mystery in regards to spiral galaxies, and specifically galaxies we refer to as grand design, the ones containing spiral arms. And so let's talk about some of these studies in a little bit more detail, but I guess let's start with the basics. And the basics being types of galaxies out there. Generally speaking, when it comes to most galaxies discovered so far, they basically fall under one of three categories: elliptical galaxies, spiral galaxies, or irregular galaxies. And though we do have some additional examples like peculiar galaxies or lenticular galaxies, for the most part, the majority of shapes out there falls under one of these three categories. And so, for example, we know that irregular galaxies usually form as a result of some kind of a disruption, most likely through collision of galaxies, or through a disruption of smaller galaxy by a larger galaxy. That's basically what happened to nearby galaxies Large Magellanic Cloud and Small Magellanic Cloud. But when it comes to spiral and elliptical galaxies, the story is a little bit more complicated. Mostly because of various discoveries from the James Webb and from some of the more advanced telescopes that became operational in the last decade. But it's really the elliptical galaxies that were always a little bit mysterious. What you're looking at right here is the example of the largest galaxy known to us, IC 1101. And one of the questions in modern cosmology has always been about their formation. What exactly caused them to form, and why do these galaxies get so large, but also become so inactive over time? And that's because by definition, a typical elliptical galaxy, which basically looks like a kind of a stretched circle, or some kind of an oval, will usually contain no defining features inside of it, but will also contain very large clumps of really ancient stars that have existed for billions of years, but no gas, no dust, and not enough material to form new stars. And so as a result, these galaxies will usually appear kind of orange or even red, because most stars here are pretty old, much older than the Sun. But when it came to their formation, it was always believed that they actually formed by a merger of larger galaxies, such as, for example, the Milky Way and the Andromeda. As a matter of fact, for many years, there's always been an assumption that as the Andromeda and the Milky Way galaxies collide, they'll probably eventually form some kind of a very large elliptical galaxy, somewhat similar to IC 1101. Or at least that's based on some of the preliminary simulations and a lot of modeling, and based on some of the previous assumptions. And so the initial scenario, or I guess the initial explanation, was that you had a collision between two large galaxies that would then result in a much larger elliptical galaxy that would eventually settle down and assume a kind of a ovalish shape. But the problem here was that, for the most part, most of these galaxies had really old stars, over 10 billion years in age, which would require these galaxies to be formed from very early large galaxies, which technically should actually lead to enormous star formation as opposed to a quiescent galaxy that we usually observe. In other words, the formation of most of these elliptical galaxies was still very difficult to explain and would not make a lot of sense for some of these older galaxies. Or at least if we assume that they formed as a result of a massive collision. And so the question of their shape and their ancient stars was somewhat difficult to answer. But luckily for us, we now have even more data from the famous ALMA, Atacama Large Millimeter Array, that was able to discover something about the birth of these galaxies in the early universe. And so here, in a study by Qinhua Tang and her team, researchers used the observations from the ALMA telescope to uncover dust we've never seen before in a lot of ancient galaxies. And specifically by looking at over 100 distant galaxies and focusing on the distribution of dust in these galaxies, mostly focusing on galaxies between 2.2 and 5.9 billion years old, which is basically during the so-called cosmic noon when most stars formed in the entire universe, researchers discovered a lot of dust in these galaxies, which in many cases was very compact, and was actually very different from what was expected from a typical disc-shaped galaxy. And because in this case this dust indicates the presence of gas, which is then responsible for the formation of stars, here this allowed the scientists to identify star-forming regions. But by modeling the shape of this dust and by trying to figure out how these stars were forming, they did uncover an unusual surprise. Here, all of these star-forming galaxies seem to be actually spherical and not disc-shaped. In other words, during this cosmic noon, a lot of galaxies that were forming massive amounts of stars instead of being elliptical like previously believed, seem to contain enormous spherical regions of star formation that in terms of shape actually resembled a typical elliptical galaxy. In other words, they basically discovered dust that was shaped just like your typical elliptical galaxy we observe today. With the new question being what exactly was happening here and why was this gas shaped this way? And so here, through additional modeling and through cosmological computer simulations, the new explanation involved very large streams of cold gas, mostly from surrounding galaxies, that through the process of galactic interaction and galactic merger, drove all of this gas into star-forming cores, creating these very compact but basically spherical regions deep inside these star-forming galaxies. And so just to rephrase this, because the galaxies back then were much closer and interacted much more frequently, all of this interaction eventually produced these very large spherical regions that would suddenly form a lot of stars and eventually use up all of this gas, leaving nothing behind. And after billions of years, it kind of resembled this, a typical elliptical galaxy. And so basically here we finally had some actual observational evidence for how elliptical galaxies most likely formed. But unfortunately, when it comes to the disk galaxies, and specifically grand design disks with spiral arms, the story gets a little bit more complicated. And that's because despite observation of some of these disks in the early universe, it was always assumed that the grand design itself, with a stable disk and a lot of spiral arms, would not form for the first few billions of years. And that's because, as mentioned before, a lot of these galaxies were interacting quite a lot, and a lot of these galaxies were very clumpy, very compact, and thus did not possess very stable shapes. And so a typical spiral galaxy with permanent formations like spiral arms, this is an example of Messier 77, would very likely take at least a few billion years to form. But as always, the observations from the James Webb Space Telescope seem to suggest that these assumptions were once again incorrect. And so the new mystery now is the formation of spiral galaxies. And all this is based on the study by Rashi Jain and Yogesh Wadadekar that used the data from James Webb to discover this grand design spiral galaxy only 1.5 billion years after the Big Bang. And since most of the other spiral galaxies found so far always appear to be much younger and did not have such a stable formation, it makes this discovery, galaxy known as A2744-JWST Z4, a very strange exception. Here, despite the young age, we seem to have two well-defined spiral arms. They have never really been seen at these distances. All of the previous discoveries of spiral arm galaxies were much closer to us, and basically when the universe was already much older, at least 2 billion years old. But here with the redshift of 4.03, this is when the universe was just over 1.5 billion years old, with this galaxy already possessing a lot of shapes usually associated with the grand design. Moreover, this is already a really massive galaxy, at least 10 billion solar masses in mass, which this galaxy seems to have accumulated in a very short period of time. But because a lot of these early galaxies were always super hot, very compact, and produced a lot of stars, the spiral and the arms technically should not be possible. Yet the observations suggest otherwise. But here one of the potential explanations is one of the features visible in the picture, the central galactic bar. In the vast majority of spiral galaxies, this feature usually causes starburst along the spiral arms, and also guides the gas between the inner and outer regions of the galaxy, affecting the motion of stars and gas, and thus growing the arms. But once again, it was always believed that this was a kind of a mature phase phenomenon, with only older galaxies being able to form these features. And so in that sense, the scientists from one study were able to solve the mystery of elliptical galaxies, but the researchers from the other study ended up creating a new mystery in regards to spiral galaxies. And so at least for now, this is going to remain a mystery until future observations, which by itself I guess is kind of ironic, because a few years ago it was actually the elliptical galaxies that were more mysterious and the spiral galaxies were believed to be well understood, but the observations from the James Webb and the observations from ALMA pretty much changed everything. It looks like now the elliptical galaxies are actually more or less explained, and it's the spiral galaxies are creating a new mystery. And today we're going to discuss ring galaxies once again, but specifically a very bizarre discovery that actually nobody expected of a galaxy with 9 rings. and actually almost perfectly circular rings, making this a very unique and obviously never before seen discovery, but also surprisingly providing a direct evidence for a relatively old theory of how these galaxies very likely formed, how they evolve, and what's going to happen to all of these rings afterwards. But first, I guess let me show you the image of the galaxy before we discuss what you're looking at. And well, here it is. This is a galaxy known as LIDA 1313-424 that's approximately 570 million light-years away from us. And just like so many other galaxies, this one was also discovered completely by accident. And only discovered because of those rings that suddenly appeared in some of the observations. Now normally when we look at these galaxies and when we actually find rings in them, it's already considered to be a relatively lucky find. For example, the famous Hawks object that basically contains this really large ring around it is still one of the most mysterious and one of the most well-known ring galaxies, but we obviously have a lot of other examples, such as the famous Cartwheel galaxy, imaged by the James Webb. And when looking at all of the galaxies discovered so far, these are actually pretty rare. Only about 1 in 10,000 galaxies is a ring galaxy, and in most cases they do appear quite different. Here's another interesting example, NGC 922, that contains rings of unusual shape, whereas this example, ARP-10, seems to contain a ring and somewhat unusual misshapen split arms that used to be part of the spiral structure. And here is one of the stranger shapes, a galaxy known as ARP-417. This is actually a combination of two galaxies that are essentially merging together, forming a ring in the process. And while when it comes to a lot of these ring galaxies, all of them seem to have formed through some kind of a collision. Here's actually one of the most famous examples of how we think this happens, visible in ARP-148. Basically a collision between some kind of a large spiral galaxy and something maybe a little bit smaller that usually passes through the galaxy, disturbing it in a process, which then ends up forming rings. We actually call these CRGs or collisional ring galaxies, and very often they differ in shapes depending on what kind of a galaxy collided and depending on the angle. Now usually when it's two larger galaxies, they'll actually produce something a little bit more misshapen, so kind of similar to what you see right here, or even right here. But in some cases we actually do find galaxies that basically have almost perfect circular rings, and in some cases their origin was a little bit more difficult to explain. Now as I mentioned, the most well-known and still the biggest mystery is the famous Hawks object, and if you actually want to learn more about this particular object, the video in the description talks about this in detail, but there are a few galaxies out there that do seem to contain perfect rings, and very often no exact explanation on how they formed. But a few decades ago, there was a potential proposition and a potential explanation still involving galactic collisions. Here, this would have to be an almost face-on collision with a much smaller galaxy, usually at least 10 times less massive than the central galaxy, which will essentially result in ripples moving away from the center and star formation along those ripples, which then basically appears as rings. And interestingly enough, only a few months ago, we actually got to see this galaxy. This was captured by the National Astronomical Observatory of Japan, and it's a galaxy approximately 800 million light-years away from us in the constellation of Aquarius. And what made this galaxy kind of special is the fact that it contained multiple perfect rings equidistant from the center, in some sense providing us with direct evidence for this hypothesis of galactic formation involving rings, with this galaxy basically being the record holder, 3 rings. And it didn't take long to beat this record by using new observations from the Hubble and from the Keck telescope. And here we had this gigantic spiral galaxy, approximately 2.5 times the size of the Milky Way, that didn't just contain the rings, but also contained a very small trail that connected this galaxy with a small dwarf galaxy that passed right through its center. Now here the actual impactor is much smaller and is not as easily visible, but it's definitely there, approximately 130,000 light-years away from the main galaxy, and it seems to contain a leading trail of gas that remained after the collision, which in essence tells us exactly what happened in this case and what formed these rings. This galaxy is now nicknamed Bullseye, and that's because in this case, this was basically a bullseye-like collision right through the center of this galaxy, as a much smaller dwarf galaxy passed right through it, producing very similar effects to what we usually expect from a tiny rock falling in the pond, with the rock in this case visible in this image as this unusual blue dwarf galaxy that's just a little bit to the left of the bullseye. With all this very likely happening approximately 50 million years ago, and every single ring forming in the center and traveling to the outskirts of this galaxy during this time. And here is roughly how this galaxy compares to the Milky Way if seen from the top. but here the oldest rings are no longer easily visible. As a matter of fact, it took a little bit of extra effort to discover all of them. But by using the WMKEC Observatory and the Hubble telescope, Imad Pasha, Peter van Dokkum and their team definitively confirmed the existence of 9 rings, with the oldest ring approximately 250,000 light-years away from the center. And this, of course, directly confirms the predictions from before and provides evidence for the formation of ring galaxies through galactic collision. And basically here the rings very likely moved outwards from the center of the collision in pretty much exactly the same way as predicted by various models. And interestingly, in that theory, the existence of these multiple rings was predicted, but we've never seen any galaxy containing so many rings in order to confirm if it was even possible. And yet here we have a galaxy that confirms everything and tells us exactly how these rings spread in the last 50 million years, with the first 2 rings extremely likely spreading out in much wider circles and also forming relatively quickly in the first few millions of years. But the additional rings very likely took much longer time because the flyby of the smaller galaxy mostly affected the first rings, giving them the most boost. And so the additional rings afterwards were created as a kind of an after effect. But I guess what's really interesting here is that none of the individual stars were most likely affected at all, and specifically their orbits. It's as if the galaxy passed through the larger galaxy, but none of the stars even noticed it. And that's mostly because of the distance between the stars, and also the overall smaller mass of the dwarf galaxy, which are unlikely to have changed the orbits of the stars too much. But it did pile up some stars into larger groups in order to form certain ring-like shapes. And much more importantly, it affected the dust and the gas. All of the gas was suddenly carried outward and started mixing with a lot of dust that was already present here, which then led to the formation of new stars visible as these very bright blue patches. This is of course a very similar phenomenon we usually observe in a lot of other ring galaxies. And so all of the new starburst activity was extremely likely caused by this collision. But in this case, because this was a face-on collision, literally right through the center, it didn't actually change the shape of the galaxy too much. But in galaxies like the cartwheel, where it was not a perfect collision, it did transform the shape just a little bit. In some other examples, this is much more extreme, especially if the mass of the collider is much bigger. And so in some sense, this is actually the first ever example we have of such a perfect collision between a large galaxy and a small galaxy, where the small galaxy dives directly through the center and causes ripples very similar to what we expect from a typical pond, and then forming these perfect rings we've never seen before. Actually, 9 perfect rings. And in this case, researchers actually suspect that there might be a 10th ring that's possibly no longer visible and very likely existed a few million years ago. But it now basically faded, especially as those younger stars went supernova, leaving nothing behind, with the ring itself fading over time. And if it exists, it's extremely likely at least 3 times as far away as the 9th ring in this image, essentially making this galaxy almost 400,000 light-years across. And so in that sense, when it comes to this galaxy, this is just the beginning of research. There are still a lot of unanswered questions, especially questions when it comes to star formation, but also questions in regards to improving current models in order to help us understand how these galaxies evolve for billions of years. Because as I mentioned in the beginning, this galaxy, the hoax object, is still actually extremely mysterious. The origin of the rings around this galaxy are currently unknown, and quite a few similar objects exist out there that cannot be explained easily. And so these very bizarre galaxies, with very strange rings around them, still have so many questions to answer. But when it comes to recent unusual galaxies discovered in the last few years, this is definitely one of the most exciting. And today we're going to discuss some of the new updates and some of the new observations and new discoveries from the most distant galaxy we've ever seen. The galaxy that you see right here that was discovered less than 1 year ago, basically beating all previous records. And no chances are in the next few years, researchers might discover an even farther candidate, because right now this is the farthest object we've ever seen. It's obviously created a lot of excitement with many new studies and new observations trying to actually figure out what's going on here. And so let's discuss this galaxy in a bit more detail, starting with a very brief review of how this galaxy was found. Naturally, this was discovered by the James Webb Space Telescope, and specifically inside the survey known as JWST, JWST Advanced Deep Extragalactic Survey. The survey that's somewhat equivalent to the famous Hubble Deep Field, when the Hubble Space Telescope observed a single spot in the night skies over 10 consecutive days. And just like with the Hubble observations, the point here with the James Webb Space Telescope was basically very similar. Pick a point that's pretty dark and that doesn't seem to contain anything and stare at it for a very long time, essentially using long exposure. And the main purpose here was to try to find super distant, practically invisible objects that no other telescope has ever seen. And naturally, after approximately 130 hours of observations, lots and lots of new galaxies suddenly appeared in the middle of nowhere, visible in the image right here, or in the image you can explore by yourself in one of the links in the description. And though this actually looks like a relatively large image, in reality, this is actually comparable to a tiny grain of sand placed on your fingertips and then extended to an arm's length, roughly around 2 feet away from your eyes. That's essentially the size of this image if you were to look at this in the night skies. And so inside this super tiny grain, James Webb was able to detect thousands and thousands of different, never before seen galaxies. And almost right away, a few of these galaxies kind of stood out, mostly because they appeared to be extremely far away due to their apparent redshift. And obviously it took a few months to confirm them. This one eventually won. JWST Z14-0 currently seems to be the farthest galaxy we've ever seen, but the initial observations from the James Webb and the spectroscopic analysis suggested the redshift of 14.32. And in terms of actual physical distances, you can actually use this pretty cool calculator by Ned Wright from UCLA to convert any redshift into light years. And so here, 14.32 suggests that the light traveled for 13.43 billion light years, but also that it traveled for 33.9 billion light years in terms of distance. This is because of the expansion of the universe, which made the light travel a much farther distance. And so because of this discovery, in the last few months there's been a lot of different studies trying to conduct additional observations just to find out what's going on here. And so in one of the recent studies, researchers actually used a different telescope in order to confirm this galaxy and its distance using different observations. They actually used the ALMA telescope, which can see things in the microwave and can detect things a lot more accurately. And here, even though they managed to confirm the existence of the galaxy, the distance was recalculated to be a little bit closer. And this was based on super accurate microwave observations, specifically focusing on emissions of oxygen, with the observations suggesting the redshift to be 14.1793. And so here, if we actually change this, the overall distance changes by just a little bit, suggesting that this galaxy is maybe 4 million years younger than we actually thought. Definitely a minor difference. But once again confirming that this is still the farthest galaxy ever seen, and more importantly confirming that this galaxy seems to be indeed somewhat unusual. Unusual in a sense that it seems to be way more advanced than expected, but not like super advanced. So basically here it doesn't actually break major theories like the Big Bang Theory, but it does suggest that the star formation very likely started much earlier than we thought, with the first galaxies assembling earlier as well. And also suggesting that the overall star formation and the overall galactic evolution seems to be entirely different from how we imagine it to be, or from how it was previously simulated by various computer simulations such as the Illustris project you see right here. In essence, there was a major discrepancy between supercomputer simulations and the actual visual evidence. But let's actually briefly discuss exactly what these differences are. First of all, the size. Previous simulations established that around this time, or about 290 million years after the Big Bang, galaxies should be maybe a few hundred light years across. This one though was approximately 1600 light years. So basically still something like 70 times smaller than the Milky Way, but much larger than anticipated. Also surprisingly, this was extremely bright, which is of course the main reason we're able to see it. It's quite likely a lot of other galaxies are probably present here as well, we just don't really see them, but this one is super visible because it seems to be extra luminous. As a matter of fact, it seems to contain approximately 500 million solar masses in mass in terms of active stars, and that's once again several times more than expected around this period. And most of the models and most of the simulations do not predict anything like this at all, mostly because there's just not enough time for galaxies to grow so massive and so bright, and the brightness in this case basically indicates extremely active star formation, which is also unexpected during this period. This is essentially during the period referred to as the Dark Ages, which researchers always believed was basically when the stars were still kind of picking up in strength and the galaxies were only starting to form. Yet here we see something that's super active and is already growing very fast. But the much more surprising detection came from several recent studies, and mostly because of a very specific wavelength. Here this was from the MIRI instrument on top of the James Webb, and specifically the 7.7 micron observations. In more layman terms, an extremely specific wavelength able to detect very unique emission lines. And so here several independent studies confirmed the same thing. They confirmed the presence of extremely strong ionized gas emissions, and specifically the oxygen emission line known as O3, a super strong emission of oxygen that's actually never been seen before from such a distant galaxy. And because in astronomy oxygen is technically a metal, this also makes this galaxy very high in metallicity. The concept you can learn about in some of the previous videos in the description, and that is super unexpected. We actually expect this galaxy to be predominantly hydrogen and helium, yet this strong emission line of oxygen suggests otherwise. Essentially here what we're seeing is a somewhat metal-enriched galaxy that seems to have already existed 294 million years after the Big Bang, once again confirming that the galactic formation theories are currently incomplete, but also definitively confirming that the early universe was just extremely different from how we imagine it to be. Here this kind of reinforces the idea that a lot of galaxies in the early universe potentially evolved much more rapidly and with intensity that we never imagined. This has actually also been confirmed by observing a lot of different quasars and a lot of unusual objects we discussed previously referred to as little red dots. You can learn about this in the video in the description. And so here right now the best explanation we have that once again seems to be aligned with the observational evidence is that this galaxy potentially had an extremely powerful starburst activity or some kind of a massive star formation burst in the last few millions of years that suddenly enriched this galaxy with highly ionized oxygen molecules that are now emitting so much bright light, specifically ultraviolet light, that it's visible from billions and billions of light years away. And because it's so far away from us, this light has been redshifted to be visible in 7.7 microns, or basically mid-infrared. But because we now see signs of metallicity in a super distant galaxy, it definitively confirms that even inside this galaxy, it already experienced several very powerful supernovae that managed to convert all of this primordial hydrogen into much heavier elements such as oxygen. And because this is a continuous event with a lot of powerful stars nearby, this oxygen becomes ionized and becomes super bright. And so right now researchers believe that this galaxy very likely has been doing this for at least 100 million years, implying that this galaxy is approximately 100 million years old, but also putting the birth of this galaxy right at the edge of the Dark Ages. So this galaxy seems to have been born as soon as some of the first stars formed as well. And right now these observations are extremely accurate. Here we have 43 hours of observations with the MIRI instrument and 167 hours with the NIRCam. This actually took approximately 9 days of observations in total. And so the existence and the overall properties of this galaxy have been measured extremely precisely. But there are obviously still some things that don't really make sense. And so some of the studies try to solve this by basically trying to imagine, or essentially trying to explain, what this region was like just a few 100 million years following the Big Bang. But here some of the conclusions can also be made by not what we can see, but also what we can't see. And specifically here researchers do not actually see any carbon, and specifically the C2 emission line, which very often represents cold gas or molecular gas, usually detected in many different galaxies, which basically suggests that this is a galaxy with extremely ionizing conditions, or extremely bright, very powerful and very massive stars, emitting a lot of ultraviolet light and a lot of ionizing radiation, which to the scientists behind one of the studies in the description suggests that this galaxy is extremely likely surrounded by a lot of neutral gas, or essentially this pristine primordial hydrogen gas that was present everywhere in the early universe and is usually the reason why a lot of galaxies far away become invisible in certain wavelengths. And so in a nutshell we have a galaxy that seems to be evolving really quickly and seems to also contain extreme interstellar medium conditions with a lot of ionized gas and ionizing radiation inside of it, but as expected is also surrounded by a lot of neutral hydrogen and a lot of cold gas, which in some sense once again confirms many other theories and many other predictions. And so in that sense the Big Bang theory and all of the ideas we have about the evolution of the universe are still more or less correct. It confirms the Dark Ages, the presence of neutral hydrogen, and the ionization of this gas by some of these early galaxies. But one of the more important discoveries in this case is actually the fact that we even found this galaxy, since this galaxy was discovered in a tiny piece of the night skies, comparable to a sand grain approximately 2 feet away from your face. Here this also suggests that many such galaxies are very likely going to be discovered in additional observations in other regions of the night sky. And those additional observations will very likely explain a lot more. But at the moment, what we can say for certain is that this is indeed an extremely active and rapidly evolving galaxy that seems to have formed quite rapidly within approximately 100 million years and already contains more stars and even more metallic materials compared to what we thought is possible. Looks like it's another day and another bizarre galaxy discovered by the James Webb that once again makes no sense, or at least is very difficult to explain based on modern cosmological theories. And in this case we're talking about this galaxy, a tiny red dot super far away that seems to be producing emissions it should not be producing. And so let's talk about this discovery in a little bit more detail, talking about the mystery and potential resolutions. But I guess first of all, what exactly is this galaxy and where is it located? Well, like so many other unusual galaxies discovered by the James Webb, this one is also from the famous survey known as JADES, JWST Advanced Deep Extragalactic Survey, that's already discovered so many strange galaxies, including some of the biggest record holders. And in some of the recent videos in the description, we've talked about some of the biggest discoveries, and actually some that also didn't really make much sense, such as the discovery from the most distant galaxy that seems to contain a lot of metallic elements, including things like oxygen, which nobody thought would be there. But this galaxy, JADE GSZ13-1, is a little bit closer. It's still about 33 billion light years away from us, but in terms of when it existed, the picture from the most distant galaxy is coming from the universe that's only about 294 million years old. Whereas here the universe is about 330 million years old. So approximately 35 million years difference. Technically though, this is basically the same period. But more importantly, this is basically the end of these so-called dark ages, the beginning of reionization. And so in order to understand this discovery, we actually do have to discuss the dark ages a little bit more and talk about this reionization. Now in case you're familiar with this, you can use that skippy thingy below me and go to the next part. But let's briefly talk about the dark ages. The universe suddenly cooled down and a lot of super hot plasma recombined into actual atoms and formed some of the first gas, mostly containing hydrogen, helium, and a little bit of lithium. And this is of course when we start seeing this first light, cosmic microwave background. And well, for the next 200 million years or so, it's always been believed that the universe basically remained more or less dark and filled with a lot of neutral hydrogen. Or basically hydrogen that was not ionized, but also hydrogen that usually absorbs a lot of high energy light. For example, UV light or even gamma rays and X-rays don't actually go through this gas, and instead by interacting with it, they ionize hydrogen and get absorbed in the process, which as a result created a bit of a problem for modern cosmology. Some of the earliest and some of the most powerful light, which very likely produced UV radiation, and of course a lot of X-rays from things like black holes, is technically invisible to us. So during the dark ages and during the early period of reionization, a lot of these high energy photons basically got absorbed by something, which made the universe opaque in a lot of high energy observations. And we actually have so much evidence about this period from a lot of these distant galaxies. As a matter of fact, there's even an entire type of galaxies known to us whose light usually tells us that they're really far away and seem to be located inside this neutral gas. And the most famous type is known as Lyman break galaxy. Galaxies that can only produce light that's less than 912 angstrom in wavelength. Or galaxies whose spectrum will always have this bizarre break. And it's called Lyman break because it's related to Lyman limit and the Lyman series, which is basically hydrogen emission lines that looks something like this. These are hydrogen spectral series resulting from the UV emission lines of hydrogen when the electron goes from one energy level to another. And this is essentially a telltale sign that something seems to be blocking a lot of this high energy light coming from these galaxies, with that something always being predicted to be this neutral hydrogen. But as more and more stars and as more and more galaxies became active, they very slowly reionized the entire universe, which slowly transformed all of the neutral hydrogen in the universe into ionized hydrogen, making the universe once again transparent. But because a lot of this is still based on a lot of predictions and a lot of theories, one of the main missions for the James Webb was to basically understand how and when this happened, how long it lasted, and of course, what actually caused the reionization. And this reionization period was previously discussed in a video in the description, because scientists now believe they know what actually did it, in this case, very powerful dwarf galaxies, but the timeline and some of the additional anomalies still don't really make sense. And in this case, we now have another anomaly that's difficult to explain. This little red dot. And this is an anomaly for so many reasons. First of all, here researchers don't even know exactly what this is. Little red dots have been discovered before, and once again, a video in the description talks about them more. But here, unlike previous detections, and unlike previous galaxies and even previous distant black holes, the spectroscopic analysis revealed something that definitely stands out. We get Lyman alpha emission. Not a drop-off, not a break, but an actual emission from something super powerful producing UV light, which at these distances should not be visible. Once again, all of the previous detections, even from much closer galaxies, always have a drop-off or a break. Or basically, in certain UV frequencies, these distant galaxies should be completely invisible. But not this one. Wherever this red dot is, it's super visible and super bright, and produces a telltale sign of the Lyman alpha emission that has never been seen so far away, with some of the galaxies that appear so much similar only seen at much closer redshifts. Here the redshift is usually less than 9. But even in these cases, the Lyman alpha was never this bright. And moreover, the nature of this galaxy is also currently difficult to explain, because here this is something super compact and something very powerful, and something that's obviously producing huge amounts of radiation. Now obviously this could be a very large population of super hot massive stars, or possibly even population 3 stars, the first stars in the universe. It could also be a powerful central black hole, or a combination of both. And so whatever this is, we've never seen anything like this before. For example, if this is a central black hole, this would be the most distant supermassive black hole we've ever seen. And here, depending on its mass, it will potentially create some other problems for some of the explanations in regards to black hole evolution. Whereas if this is just stars, it's not clear why these stars seem to produce and seem to even leak so many ionizing photons that seem to be invisible in every other galaxy. And so for some unknown reason, somehow this galaxy seems to be shining through this neutral hydrogen fog, ignoring a lot of previous assumptions we had about the early universe. Now once again, this is only 330 million years old, or basically one of the earliest galaxies we've ever seen, and it's definitely located right at the start of this reionization period. Now here the mystery could be resolved if this was much closer to us, or in much older universe, but this recent study definitively confirms the redshift. And this was actually achieved by measuring this Lyman alpha emission, and by confirming the redshift to be 13.05. In other words, the distance to this galaxy was actually confirmed by detecting this super powerful light from ionized hydrogen. But at the same time, we actually still see signs of some absorption, suggesting that this was indeed during the cosmic reionization period. And so in that sense, it does not break theories of reionization, it just seems to be some kind of a really bizarre anomaly. This super powerful ultraviolet light currently just cannot be explained. But nevertheless, researchers do provide some potential explanations. Here they basically think that this galaxy, or whatever this object is, created a kind of a massive bubble around itself that seems to be already entirely ionized. It's about 200,000 light years across, or about twice as big as the Milky Way galaxy, with this very early re-ionized region possibly preventing extinction of this Lyman alpha radiation and thus allowing it to pass through to eventually reach our planet. But in order to produce such a huge bubble, and in order to reionize everything around itself, it has to be an extreme galaxy, either containing a super powerful active galactic nucleus or a black hole, or once again containing an enormous amount of very powerful massive stars. Something that's also kind of difficult to explain because this is only 330 million years after the Big Bang. And so in this case, the biggest mystery is actually what exactly is causing all of this radiation and what's producing this super bright emission. Here, the source of this Lyman alpha radiation and the source of this massive bubble is completely unknown. In fact, it might be some kind of a peculiar phenomenon, or maybe even some strange form of stars that were predicted in some of the previous studies but have never been found until now. And we'll actually discuss some of this in some of the future videos once we get some updates about this discovery and once there are some additional observations figuring out how this is possible. Either way, whatever this is, it seems to be much hotter, more luminous, and more powerful than anything we've seen at this early stage. And because it's so tiny and so compact, we don't really know what it is. But because these little red dots are technically an ongoing mystery, you might want to check out more about them in one of the previous videos in the description. These strange phenomena, these unusual objects, seem to be all over the ancient universe, and right now there is no exact explanation for what they are or for what became of them as the universe evolved. But there have been similar detections at much closer distances, specifically a redshift of 8 or even close to 9, so this is not something that's absolutely impossible. It's just extremely unlikely. We're going to discuss a discovery of a very strange galaxy whose existence is currently very difficult to explain, and specifically because this is a super rare type of a galaxy that contains extremely long radio jets, but is not your typical elliptical galaxy like the ones that usually produce this. This seems to be a giant spiral galaxy, extremely similar to the Milky Way, but much larger in size. And so let's discuss this discovery and what this means, starting with the idea of these radio galaxies and what type of galaxies usually produce these enormous radio jets. Now, in some of the previous videos, we've discussed some of the record holders, specifically radio galaxies that produce some of the longest jets in the universe. And though some of them are relatively short, some seem to have jets over 20 million light years in length, essentially making these some of the largest structures in the entire universe. And so by definition, a lot of these galaxies are essentially defined by these enormous radio jets, or jets mostly visible in radio light that usually extend way past the actual galaxy. But they're also usually extremely bright and obviously contain a lot of energy. And because of the advances in radio telescopes, quite a lot of these new radio galaxies have been discovered in the last 2 decades. But pretty much most of them seem to contain elliptical galaxies in the center. Here we're talking about galaxies whose shape resembles something like this. This is the famous Messier 87. And though certain spiral galaxies have been known to produce occasional radio jets, such as for example the so-called Seyfert galaxies, like the one you see right here known as the Circinus galaxy, here the radio jets are usually extremely small and are only visible in the local universe. One of the most famous such jets is the one in the Centaurus A galaxy. This is basically one of the nearest such galaxies close to us. But up until recently, it was actually believed that it was really only elliptical galaxies that could produce jets 100 times larger than the host itself. As a matter of fact, previous studies have also established that things like, for example, quasars and blazars that are also known to produce these powerful jets are extremely likely elliptical galaxies as well, with the overall explanation for this being that they most likely contain much more massive black holes, like for example the one inside M87 is approximately 1500 times more massive than the one in the Milky Way, and they're also possibly just a little bit more effective at somehow feeding the black hole. Or basically, a really large amount of cold gas inside spiral galaxies possibly disrupts the formation of the jet and prevents radio jets from forming. Likewise, a lot of these elliptical galaxies are usually in the middle of extremely enriched environment, containing a lot of gas around themselves, which then allows the energy from the jet to form various radio sources. Although the exact reason for why it's usually elliptical and not spiral galaxies is still obviously not entirely clear. But in 1998, researchers discovered the first hint of a spiral with a large radio jet. In this case, the observations were not very clear at first, but by 2011, the existence of spiral galaxies with large radio jets was officially confirmed, with this one being the first object, J0313-192, but this here becoming the most famous, the galaxy known as Speca, 1.7 billion light-years away from planet Earth. And when it was discovered, this was basically the spiral galaxy with the longest confirmed radio jet, which basically formed a new type of an extremely rare galaxy out there. These are now known as the spiral dragon galaxies, or spiral double radio source associated with galactic nucleus, sometimes also referred to as the Speca-likes. But they're so rare that there's basically only a handful discovered to date, with the majority actually discovered in just the last 2 years. And once again, this is mostly because of the advances in radio telescopes and a lot of new surveys that are focusing on scanning the entire night skies. And so now we had the official confirmation that spiral galaxies can also launch relatively giant radio jets and can also even be episodic in nature. very similar to what we usually observe around a typical radio galaxy, such as those record holders I showed you previously. But that's despite the fact that they all contain an extremely stable and usually massive spiral, with the only main difference between this spiral and a galaxy like the Milky Way just being the color itself. These galaxies are usually just a little bit more red on the optical spectrum, and there's a really good explanation for this. Because they produce these enormous jets, which of course is the result of the superactive central black hole, we basically expect the environment around the black hole to eventually change a lot of molecular gas and to shut down star formation, leaving behind only ancient red stars. And so essentially here, because of the superactive central black hole, the extra energy emitted from the center eventually displaces and changes a lot of gas around the galaxy, making star formation extremely difficult. And while something extremely similar has now been discovered in this new galaxy that basically beats all records. This new galaxy, known as J2345-0449, seems to possess giant radio jets and also seems to be a super spiral, 3 times larger in size compared to the Milky Way, but also potentially containing way more mass, which has now been explained as the excess dark matter. And this also basically implies that it potentially contains an extremely massive central black hole, possibly hundreds of times more massive than the one in the Milky Way. And even though our own galaxy, the Milky Way, also shows signs of previous activity, such as for example the famous Fermi bubbles discovered a while back, here this is only approximately 50,000 light years in length. In comparison, this jet is 5 million light years. So that's basically 100 times larger, and obviously containing way more energy. But once again, right now, it's not clear exactly how this formed or even what caused this, because here this would require the black hole to feed for a very long time and possibly consume a lot of gas coming from somewhere else. But because here the giant meter wave radio telescope and ALMA telescopes confirm the lack of star formation and the size of the jet, it essentially implies some kind of an extremely violent past that potentially lasted for millions if not billions of years. And so here the central black hole very likely heated up the entire galaxy and a lot of gas inside of it, preventing it from collapsing into new stars and pushing it away from the galaxy. But in comparison, the central black hole in our own galaxy, Sagittarius A star, is currently believed to be incapable of doing any of this and is just not large enough to produce anything just as massive. Moreover, it's unable to completely shut down the activity in a galaxy, even if it suddenly becomes active. And so in that sense, having a smaller central black hole in a galaxy is actually beneficial to long-term star formation. But in this particular case, based on the shape of the stars near the galaxy, researchers believe that it's possible that the black hole in here and the stars around the galaxy potentially evolved separately. As in, the black hole seems to have evolved separately, as opposed to gaining mass from various galactic mergers like we usually expect, which right now is somewhat difficult to explain, but suggests that these unusual galaxies can maybe help us understand how galaxies evolved to begin with, and also potentially help us understand the mysteries behind dark matter, because in this case, as I mentioned before, for some reason this galaxy seems to contain an excess dark matter and excess mass. But there's another small thing I wanted to mention in regards to the press release and some of the implications from the actual title. Here, this was released by the Royal Astronomical Society, and the title was somewhat misleading. Cosmic Anomaly hints at frightening future for Milky Way. I mean, obviously it made me click on this to try to understand what's happening, but the main point the author is trying to make here is that because this is a spiral galaxy and because it has these enormous jets, one day this might happen to the Milky Way and it might doom us all. So, start packing. Except that that's kind of completely incorrect, for reasons I already mentioned, but just to highlight this again, the Milky Way galaxy is just unable to form anything like this because our black hole is not big enough, and even if it could form a jet, it's actually not even pointed at us and will never point toward planet Earth. Moreover, we actually don't even understand the effects from these jets on various planets. As a matter of fact, extremely recently, there was another study released by Kendall Sippy and the team you see right here that actually argues something entirely different. Based on simulations and somewhat accurate calculations, they actually suggest that a typical black hole jet might be beneficial to a typical Earth-like planet, in a sense that if the planet contains oxygen, it might actually dramatically increase the formation of ozone, preventing other radiation from reaching the surface and potentially creating more habitable conditions. Here, the calculations assume a somewhat average active galactic nucleus releasing a lot of energy toward our own planet, which means that, in theory, if this actually happens to the planet, it might even be somewhat beneficial, assuming there is oxygen produced by something. But despite the misleading headline, this is still a super exciting discovery. We've actually never seen anything like this before, and this is the first spiral galaxy, massive spiral galaxy, producing such an enormous jet that's actually much longer than some other radio jets from elliptical galaxies we've discovered previously. But because this is a new discovery, we don't really know much else. Hello wonderful person, this is Anton, and today we're going to discuss some of the more unusual discoveries and some of the more unusual studies about our neighbor, the Andromeda Galaxy. The galaxy, also known as Messier 31, and essentially the largest spiral galaxy next to the Milky Way at a distance of 2.5 million light-years. And a galaxy that seems to be on a collision course with the Milky Way, but that collision is still uncertain. But what is certain is that the galaxy seems to be a little bit unusual and doesn't actually seem to fit a lot of models and cannot be easily explained using modern cosmology. As a matter of fact, you could almost say that this galaxy surprisingly violates modern cosmology, at least to some extent. And so in this video we're going to discuss one of the recent studies that once again confirms this bizarre anomaly, but unfortunately also doesn't actually provide any explanation whatsoever. But first I wanted to start with one of the most recent studies in regards to its center, because even here we have some new discoveries. And this is in regards to the central galactic region that basically contains the supermassive black hole. And obviously, like so many other galaxies, including the Milky Way, the Andromeda Galaxy also contains a black hole. But compared to the Milky Way, this one here is actually a little bit too massive. In a recent study here, the mass was confirmed to be approximately 100 million solar masses, or about 22 times more massive than the one in the Milky Way. And here, even though the galaxy is just a little bit bigger than the Milky Way, for some reason it seems to contain a much more massive central black hole. This might actually become important in a few minutes. But it also is surprisingly quiet. It's only showed occasional signs of activity, and for the most part seems to be surrounded by a relatively dense cluster of stars, making this a highly populated region. As a matter of fact, one of the strange features in this galaxy is the fact that it seems to contain two central regions, or basically two large concentrations separated by about 5 light-years, in this image designated as P1 and P2, with both regions containing a lot of really bright A-type stars and huge amounts of dust. But exactly why there is a double nucleus has always been a bit of a mystery. Now, one explanation suggested that maybe one of these regions is just a bunch of stars orbiting around a central black hole, with a lot of these stars potentially having a very high eccentricity, so they move really far away from the black hole. But how this would form is of course unknown. Obviously, a galactic collision or a black hole collision could have created something like this, but there's really no evidence for anything yet. Alternatively, maybe the second nucleus is some kind of a remnant of an ancient galaxy that was basically absorbed by the Andromeda a very long time ago. But this is now believed to be maybe not a good explanation, simply because such a nucleus should not exist for so long and would have already broken apart a long time ago. Either way, this has always been a bit of a mystery. But because this galaxy is so close to us, to astronomers this is a perfect opportunity to study how galaxies evolve alongside central black holes. And that's because here we can actually see the galactic core pretty well. And so not so long ago, scientists were able to combine observations from the X-ray observatories, such as the famous Chandra telescope, with detections of neutrinos by facilities like the IceCube neutrino detector in Antarctica, with these new discoveries basically linking neutrino production with X-ray flares. We're essentially confirming that whenever we see more neutrinos coming from this region, it seems to be connected to the supermassive black hole, because we also see X-ray flares. And even though X-rays were coming from several regions, with the region you see right here known as SSS producing a lot of X-rays, surprisingly it's the region known as P2 that was producing most of the neutrinos, which has already been suggested as the main region where the black hole seems to reside. And so here once again P2 was confirmed to be the home of the central black hole, as suggested by previous studies. But more importantly, scientists have also confirmed that for some reason Since 2006, this black hole has actually been in a kind of a state of elevated activity. Or basically since 2006, it was actually producing quite a lot of flares for reasons that are still unknown. There was a major eruption in 2006, there was another one in 2013, and more are expected soon because even now, there seems to be an elevated X-ray flux. Or basically the black hole seems to be producing more X-rays than it should. And so there are definitely quite a lot of mysteries right here in the center. But a much bigger mystery that was also described in one of the recent studies was just discovered coming from the outskirts or from various dwarf galaxies around the Andromeda. And while technically the Andromeda galaxy's dwarf satellites have always been a bit mysterious, mostly because of their orbit. For example, back in 2006, one of the major discoveries about this galaxy was that for some reason, quite a lot of companion galaxies here were actually orbiting in a kind of a single plane. And here's one of the images produced back in 2006. Basically here, several galaxies orbit in a kind of a polar plane. And it was not entirely clear why or how to explain this. We obviously expect planets to orbit in a single plane around a developing star, but this is not expected of a galaxy. Based on various galactic simulations such as Illustris project and specifically TNG-50, we actually expect a lot of these dwarf galaxies to kind of orbit all over the place. This is referred to as near isotropic, which is kind of expected of all galaxies, and is sort of observed around the Milky Way as well. Yet here the Andromeda didn't seem to possess this, at least for some of these galaxies. But in this recent study, the mystery kind of intensified. The study by Kosuki, Jamie, Kanehisa, and the team you see right here, surprisingly confirmed that many satellites around Andromeda seem to have a bizarre asymmetry. And asymmetry that's super difficult to explain. Here, of all 37 known dwarf galaxies, 36 seem to be positioned in a way that makes no sense. They're essentially contained in a kind of a cone of 107 degrees toward the Milky Way galaxy. Or just to help you visualize, it kind of looks like this. Notice how a lot of these galaxies seem to be in a single location, with many of them also orbiting in this somewhat strange plane. And this asymmetrical distribution right now really makes no sense, because a lot of them seem to be aligned toward the Milky Way galaxy, and no cosmological model can explain exactly what's happening. As I mentioned, this seems to actually challenge the standard model of cosmology, at least to some extent, because in that model, these satellites are predicted to be all over the place, forming a kind of a near isotropic distribution. Yet 36 out of 37 seem to be in this very strange cone. And well, at first, obviously, this was assumed to be maybe some kind of a observational bias or lack of data. Or basically, maybe we're just not seeing many other galaxies far away from the Milky Way, just because closer galaxies are much easier to see. But despite improvements in our telescopes, and despite even better observations, this still seems to persist. This is despite the fact that we discovered new satellites, and despite the fact that some of the brighter satellites are actually on the far side in this video. And so even though there might be some observational bias, it does not seem to answer everything. Alternative explanations suggest that this could be the result of a tidal interaction, or even a collisional interaction, between the Milky Way and the Andromeda. And that's because both galaxies, as I mentioned before, are expected to collide in the next 5 billion years. But calculations in the study suggest that tidal effects cannot actually produce anything like this at all. Just because the galaxies are still far away from each other at 2.5 million light years, and the tidal effects in this case would be absolutely minimal. Here's actually one of the maps showing us the distribution of galaxies and the distance between the Milky Way and the Andromeda. And even here it becomes pretty obvious that many of these dwarf galaxies seem to be misaligned toward the Milky Way. As a matter of fact, when modeling this, when the researchers tried to recreate this by chance, it only happened 0.3% of the time, which once again suggests that this is extremely unlikely to happen in a standard cosmological model. I mean, it's possible, just super unlikely. 99.7% unlikely. And because here the explanation is most likely physical in origin, or basically this is not the result of a bias, and these galaxies are indeed seem to be kind of lopsided, this is probably the result of some kind of a bizarre formation history for the Andromeda galaxy. But exactly what happened and what influenced this is of course unknown. As a matter of fact, even though the signs here point at the Milky Way's influence, we have no idea what influence this would be. If this was indeed the result of the Milky Way, there is really no explanation at all. Although there was one potential explanation that researchers do tackle in a study. Here, maybe this was all the result of some kind of a single accretion event where a lot of satellites from some kind of a large association all came into the galaxy at once. Or essentially this was a chunk or a cluster of satellites arriving into the Andromeda system within just a few million years. But according to researchers behind this study, this also doesn't make sense because here, such a symmetry would only exist for approximately 500 million years maximum, and many of these galaxies seem to contain very different orbits and even very different orbital energies, basically suggesting that they're moving at different speeds in different directions. So there's actually not a lot of connection between them individually. With the last explanation being that maybe we're just seeing this galaxy at this one specific moment when all of the satellites are for some reason in a single location. It's kind of like when we have the planetary alignment in the solar system with all of the planets on a single side. But since this is 36 galaxies, whose orbits take hundreds of millions of years on average, such an alignment would also be super unlikely. Not impossible, just extremely rare. Which basically leaves us with Andromeda being this unusual outlier that seems to defy cosmological theories and raises a lot of questions about Andromeda's evolutionary history and how this galaxy and its satellites formed, and especially because of that mystery of double nucleus I mentioned previously, which might actually connect to all of this somehow, but we don't really have the exact explanation yet. Basically here it seems to be the result of some kind of a massive collision a long time ago, which potentially formed this somewhat strange distribution. And because in this case there are actually two mysteries when it comes to orbits of these satellites, the first mystery being the asymmetry and the second mystery being several galaxies orbiting in a single plane, here this raises several questions on whether Andromeda is just an anomaly or if our understanding of galactic formation is maybe incorrect. And so yeah, one of the biggest mysteries in cosmology is technically right here at our doorsteps. But luckily for us, we have telescopes like the Euclid that has just begun its operation that will most likely discover even more mysteries around Andromeda and will probably provide us with some answers as it discovers more of these invisible galaxies and as the number of satellite galaxies around the Andromeda grows in the future. Once we're able to see hundreds of satellites, we'll probably be able to tell what actually happened here. But with just 37, it is maybe a bit of a bias. And so until future discoveries or until we discover something else, that's all I wanted to mention. Check out some of the previous videos about Andromeda in the description. Thank you for watching, subscribe, share this with someone who loves about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.